Blazor is a single-page application framework created by Microsoft. With Blazor, you write C# to generate dynamic content. And with Blazor, you can become a full-stack developer with C# on both front-end and back-end. My name is Frank Liu. I'll be talking about the architecture and how it works for the first 3 modules. Then we will get into every aspect of Blazor in depth. Toward the end, we will be creating a reusable DataGrid component using the knowledge that we are going to learn. Without further ado, let's get started.
Blazor is for web development. So to talk about Blazor architecture, I want to talk about 2 typical web development architecture first. The first one is the very typical request and response model, where you have a browser and you have your user interact with the browser. And whenever the user wants to see something, the browser sends a HTTP request to the server side, and the server processes the request here and returns a HTTP response. And what's in the HTTP response? It's HTML. And then the HTML will be rendered on the screen, and the user sees it, and the user is happy. So this is the first architecture. And a lot of the development technology actually uses this. For example, the original from Microsoft, the original classic ASP. Right? So ASP, and then you have JASP, and then you have the Microsoft ASP.NET Web Forms. You have ASP.NET MVC, and the ASP.NET Core MVC. Yeah, a lot of them are using this architecture with some help, with or without some help of JavaScript. And then the second architecture is more interactive. That's when the web development world noticed that this first architecture is good, but the performance-wise, it's not great. And when the development world noticed that the browser actually it runs its desktop application, it runs on the computer, and it has its own powerful computing power. And as the client computers getting more and more powerful, the smartphone also gets very, very powerful. The browser has a very powerful computing power. The storage is getting bigger and bigger as well. So then, why don't we take advantage of this computing power? So that introduced the second architecture, where we actually uses JavaScript running directly on the browser and renders the result to the DOM, right? And here, let's start from the user side. So the user interacts with the browser, and then the browser, the DOM actually sends events, like the user clicks on button, so you have an on-click event, right? And then some other controls may trigger on-change event. So on key down, on key up, those kind of events are handled in the JavaScript. And then the JavaScript sends calls the web API running on the server. Nowadays you have more options, but let's just use web API for example, right? So it sends a web API. So this is a HTTP request. And then the web API actually typically communicates with a database to get the data. So here, in this example, I was just, I didn't talk about the details here. but in the second architecture, I have to. So the JavaScript calls the HTTP, the web API, or just let's call it the REST API, and then it returns a HTTP response, typically in the format of JSON. And then the data is consumed here in the JavaScript, right? The data is consumed here in the JavaScript, and HTML is created or updated and sends to the renders to the DOM, and the user sees it. So that leads us to Blazor. So we have JavaScript frameworks, the front-end frameworks. So we have jQuery. So jQuery is probably a library. So we have front-end frameworks and front-end libraries like jQuery, React, Angular, Vue.js, all of these. Right? So we're asking a question. The React is from Facebook, and Angular is from Google. So then where's Microsoft, right? Everybody's kind of expecting that. But just recently, we have been waiting for a long time. Just recently, Microsoft came with a new technology. It's called Blazor. And the Blazor architecture is actually, there are two kinds of architecture from Blazor. One is the client side, one is the server side. And the client side is actually very, very similar to the second type of architecture. So if I can copy this, so Blazor is very, very similar to the first architecture. So the only thing that is different here is instead of using JavaScript, we're having C# here. It means that we can use C# on the server side as well as on the client side. That opens a lot of doors for us. JavaScript is nice, it's good, but then it actually evolves in a very dangerous speed. So let's also talk about the server side. So Blazor has a hosting model that is client side as well as server side, and let's start with the browser. So we also have the DOM here, and instead of having the C# code, basically the server-side hosting model, we pull the C# code from the client side to the server side. Right? So here, instead of C#, we're having Blazor. It's a JavaScript file. I forgot the name. But once we go to the computer, I'm gonna show you where the file is. So we're having the C# library pulled over to the server side, and that's why they call it hosting model. So we have the Blazor applications can call the service layer, and then the service layer can call the repository layer, and the repository can work with context, DB context if we are using Entity Framework. But how the server side communicate with the client side, that's where we have the WebSocket wrapped around by SignalR. Right, so it's a dedicated communication channel. It means that we are using, instead of HTTP request and response, we're sending messages back and forth. And so this channel is maintained constantly. And that's it's a very smart way. And this Blazor.js, this file is used to communicate with the Blazor application, our C# code there. And the performance is also pretty amazing. And this, so the architecture that we're comparing the architecture between Blazor client side and Blazor server side is that if we are with this client side application, actually, we can create microservices by creating different web APIs or, yeah. But server side, we can also do that If we do that, then we cannot call the service layer and repository layer or the context, DB context directly in the same machine, because this is monolithic. So if we're trying to do the monolithic architecture on the server side, then we cannot, it's not gonna be very efficient. And if we want to still support microservices, then we have to pull the service layer and repository layer outside to a different machine, to different hosting environment. The request response architecture is stateless. The second, the front-end frameworks architecture, we maintaining state on the client side, but this part is also stateless. Right, the communication part with the backend API. And with the Blazor client side, we're maintaining the state also in the client side. And with the server, see, the problem is that we're maintaining the state on the server. So if we're having a lot of users on the client side, that means we're going to host a lot of state. And that really we're gonna host the state on the server side for many times, and that's really costing a lot of resources. And that's going to be a issue that we need to consider. Whether or not we are having the service layer hosted somewhere else as APIs, this is something we need to consider. In the next video, I'm going to take a deeper look at the architecture, the Blazor architecture, to explain why we can host C# directly in the browser, how Microsoft does this, and then how it actually works.
Let's take a deeper look at the Blazor architecture. We have a browser here. And again, I'll draw the DOM here. And we need to be able to run the code on the browser. And how do we do that? There is this thing that's called WebAssembly. And if you go to the WebAssembly, the website, they say that WebAssembly is a compiler target. So then what is a compiler target? We have a compiler here. There's this compiler source, and then there's this compiler target. So compiler source is the source language, and compiler target is just the target language. So compiler is basically, when it compiles, it converts the source language to the target language. So for example, C# after compilation, it turns into intermediate language. And how does an intermediate language runs on a computer? So if we have a computer here, the intermediate language is not a machine language that can run directly on the computer. So what it does is that we have a .NET runtime, right? And the intermediate language actually runs within the context of .NET runtime. So if we come back to this Blazor topic, so WebAssembly is let's say it's a language that can run directly in the browser. And how can that be possible? That's because most of the vendors like Chrome, Google Chrome, Microsoft Edge, Internet Explorer, Firefox, most of the vendors, they agreed on this WebAssembly standard. And most of the products, they are able to support this WebAssembly standard. So as long as your code is written in this WebAssembly language, then there's browser supported, and it runs actually kind of like natively It runs really fast. Performance is amazing. So how can the C# run inside the browser? The answer is it runs as a WebAssembly. That's not entirely true in terms of how Blazor runs on the browser. Blazor actually we do not actually turn the C# codes into WebAssembly. What it does is that there is this thing that is called mono WebAssembly, and the mono WebAssembly is a runtime. Mono WebAssembly itself is a WebAssembly, so it runs on the browser. So if I draw another square here, and if we call this mono WebAssembly, so this is the when the server runs. So if we have server here, and if we have our Blazor application hosted in the server, and when the user sends a HTTP request through the browser, the server actually first it pushes the mono WebAssembly to the browser, right? And it is actually a runtime. It works like a runtime. So after that, our Blazor applications, the Blazor framework, as well as .NET Standard libraries, all of the dependencies of our Blazor applications will be downloaded to the server. So the next layer would be our .NET runtime. So sorry, not the .NET Standard, and the next layer. So this would be also downloaded, and right. So we have our Blazor framework here, and within the Blazor framework, our Blazor application actually runs here. So lastly, our Blazor app runs here. And how does the Blazor app actually produces the HTML? As we know that Blazor actually uses a component-based architecture, which means our developers actually created a lot of components. We create components inside the Blazor applications. So, and we call it the component tree. So for example, if we have a computer, if we have a UI design that looks like this, so we have a menu items, and then we have some area that looks like that, and within this area we have two two panels, and something is displayed here, and then something is displayed here, and then a picture maybe displayed here. Then here we actually have a component tree here, right? So we have our root component, which is this one, right? The biggest one. So we have a root component, and then we have two components on the second level, and then we have in here we have three components, right? So it's a component tree. So this component tree constantly changes when user interacts with the interface, right? So the user clicks somewhere or press keys, changes the data, so the data would be changing, and the components would be reloading. Right? Sometimes it may switch to a completely different set of components. So this component tree is actually being tracked by the Blazor application. So we would have two. So this is the previous component tree, the previous tree, and is the current tree. So whenever user makes some changes, it generates the current tree, and then it compares with the previous tree, right? So here it makes a comparison between those two, the previous tree and the current tree, and then it creates a div. It calculates a component tree div, and this component tree div will be sent to the DOM and used to update the DOM. And then the user would be able to see the changes. So this is the client-side Blazor, right? This is how it works. So to summarize a little bit, the Blazor application, they are actually, so all of these are C# DLLs, right? C# DLLs, C# DLL, and this is mono WebAssembly. This is actually a WebAssembly. So this is the client side. So the server side, let's cover server side here. The server side Blazor works very similarly, just like in our previous video we covered. But all these things actually happens on the server side. That's why it's called server side. So if I try to cover that again here, so we have a browser here, right? And then we have our DOM here. And in here, we have the Blazor, now I remember the name, Blazor server.js. And then on the server, I have to draw a bigger rectangle here to represent the server. So in here, of course, we're gonna have our .NET. If I follow the same way of drawing, we're gonna have our .NET framework. So we're not limited. We can use the full .NET framework here. It doesn't have to be using the .NET standard. We can have our .NET framework, and then within it, you can run our Blazor framework. And within it, we have our Blazor app, and then we have our previous tree and current tree. And so our Blazor applications also communicates through the signal error channel, right? Signal error WebSocket channel. So then what happens is that the user sends request, and then the message is sent over to the Blazor application, and then the components gets updated, the data gets refreshed, and the comparison happens here, and then this creates the UI div. Right, so this UI div is sent over to the browser through the Blazor server.js file, and then gets the actual DOM is updated, and the user sees the results. So that's how Blazor works in detail.
When it comes to the pros, obviously pros with the WebAssembly model is that you fully utilize the client-side resources and offloads the burden of the server, right? Because everything that is needed is already on the client-side browser. But the cons of the WebAssembly hosting model is that because it downloads everything, so the initial load is slow, and those are the main pros and cons of WebAssembly. Everything else is pretty minor, so I'm not going to mention. For the server side, there's also pros and cons.
And obviously, the pros of one hosting model is going to be the cons of the other one, and the cons of the one hosting model will be the pros of the other model, right? So for the pros of the Blazor server, the first one is you have a very fast initial load because everything is actually within the server side, and there's not much that you need to be sent to the server, right? The only thing is this UI difference, and it's very minimum because it's only the difference between the two, the previous render tree and the current render tree. Plus, this UI difference is in a binary format, right? So it's very compact. So you have a fast initial load. That's obvious for the first server-side Blazor. And also, for developers, because everything is hosted on the server side, so we can directly call the service layers, repository layers, without going through APIs, for example, REST API, right? So all of the concerns related to calling REST APIs you don't have to consider it if you choose to not incorporating the REST APIs, right? So for example, you don't have to worry about security concerns. You don't have to worry about the API mapping from the JSON results to objects and all of those things, right? So you have a much faster development speed. So it's good for prototyping. So, but what are the cons of the server-side hosting model? Because everything is hosted on the server side. Let's say you're gonna have a variable that stores thousands of hundreds of rows of data, and that data has to be rendered to the render tree, right? And you have two render trees, and because you already in the variable you already have thousands of rows, right? And then those rows has to be reflected within those two render trees. One is for the previous version, one is for the current version. So you actually keep a large amount of data on the server side, and that's just for one user. And if you have many users, imagine you use a large amount of memory for just one user session, and you have many users like this, right? You have like 1,000 users. So you gotta do like 1,000 times 3, because you have basically 3 copies of that data. One is in the variable, one is in the previous render tree, and one is in the current render tree. And then that amount of memory you use for each for that variable, right? And if you have 10,000 records in that variable, 10,000 rows, and each row takes a large amount of data, then this is going to be a huge amount of data for all of the users to use. And all of that comes from just one server, right? Your server side, this one. Whereas if you use a client-side hosting model, then all of this, well, you're not going to, first of all, you're not going to have this 1,000, right? You're going to have 3 copies. You're going to have one variable, but this is going to be on the client side. It's going to be within the browser. So as long as you have a very good client, as long as it's not a very thin client, then it's going to work. But whereas if you do this on the server side, it's not going to work. So so let's list out the pros and cons for each. So for the client side, we have what is the pros for the WebAssembly, right? So fully utilize the power of the client, right? And what are the cons? So the cons is slow initial load, right? Because there's so many files to load, like this part, so many files. And then this is the WebAssembly, right? And the server side, the pros, fast initial load, and then we have fast development, right? And what are the cons? The burden on the server. And the last one I forgot to cover is because of the signal R channel here, what if the channel, the signal R gets disconnected, right? So I personally think that if you want to create a small application, then the server side is a very good choice. And you also need to be, if you were to use the server-side Blazor to create a mid-size or big-size application, you really need to pay attention to how you load the data. Do not load large amount of data. Always load the data that you want to display, and then use paging or something like that to get the next string of data to the browser. Do not load everything. That will really slow down the process. And for the problem with the signal R channel disconnection, just always make sure that you save your data often. And so when there is a disconnection and you have to do a screen refresh to reconnect the signal R channel, then you only lose the limited amount of data. All right, so overall, I do think that a better choice is to use the WebAssembly hosting model instead of the server-side hosting model. But with very careful design, you can use the server-side model for a large project. I want to talk about the project structure of both the WebAssembly Blazor as well as the Blazor server-side. So first, I want to create a project, and it's going to be Blazor. And I'll call this Blazor WebAssembly. And I'll choose the WebAssembly template. All right, that's pretty simple. And let's run this right away. Before we go into the project structure, I wanted to show you guys something else for both the WebAssembly Blazor as well as the server-side Blazor. So if I run it, I see it's loading, and then we can see the pages, the user interface. So what I wanted to show you guys is if I use the developer tool and I go to the network tab, I have to do a refresh, you can see all these things are being downloaded. Okay, you see the loading? It takes a long time, and then all these are downloaded. So let's take a look at what are actually downloaded. So at the beginning, we have this Blazor WebAssembly JS file that is downloaded, and then this file initializes the download of the other things. This is the mono WebAssembly, which is the only WebAssembly. This is the context. So all of the other ones run within this context, as I've covered in the second video. So we can see that we have the Blazor framework, and we have the .NET assemblies, all the dependencies. We have also our application as well. So this, because I call it Blazor WebAssembly, this is the project. This is the project. So this is our application DLL, and our debug information is also downloaded here. Yeah, so that's what I wanted to show you on the client-side WebAssembly Blazor. So if I stop this for now, okay, let's open another Visual Studio instance and create another project, which is the Blazor server side. It's the same process, but this time I call it Blazor server side. Okay. And I choose the server side app. All right. So again, before I go into the structure, I want to run the app. All right. Same drill. We're going to look at the developer tool. We'll clear it, refresh, and this time let's take a look at what's downloaded. So we only have this JS file that is downloaded, and then we have this the WebSocket, which is the Signal channel. So we can see that we clear this. So each time if I do anything, clear again, click on this. See, each time I do anything with the components, the channel there is being used to pass message back and forth, because all of our components and the state of the components are actually being kept on the server side, and we're using the Signal channel to send back and forth the message. And yeah, that's also the thing that I want to cover before we go into the structure. So on the left-hand side is our WebAssembly, the client-side Blazor. On the right-hand side is our server-side Blazor. So we can see that they look very similar, and it's all based on ASP.NET Core. So the entry point is always the program files, and they're pretty similar too. I also covered the ASP.NET Lifecycle that includes the configuration as well as the middleware pipeline in one of my other videos. So this program this program file has a main method. This is the entry point of the whole application, same as the server side, and this basically builds the hosting environment of the web application. And the startup files are the actual configuration file that we can use to configure the application. So let's actually focus on our client side for now. So we have our program files, which calls our startup files to configure our applications. By default, there's nothing in the configure services which handles the dependency injection, and there's only this adding one component, which is the root components of our application. If we look at the this folder, it has the www root folder. We have index.html file, which has the basic HTML structure, and the most important thing, the two important thing here, one is this app loading thing, and this is the root component, and also this Blazor WebAssembly that I have showed you. That this one downloads all of the DLLs and initialize the runtime to start running our application. So then when this page gets loaded, the app component, which is root component, is being used, and the root component set up the router for the client-side routing, right? And then it uses the layout file which is under the shared folder, the layout file, and it provides a layout for our application. And the most important part here in the layout file is this body placeholder, which is a placeholder of all of the routable components. So the routable components are the components that has the, for example, here, has the add page directive, which tells the Blazor framework, or tells the router that this component is a routable component, and in order to get to the component, we can use this route, right? We can use this path, and when we use this path, what's happening is that this component will be displayed at the place where the add body placeholder is, which is inside the main layout. So in this add body layout, this main layout, we have this add body placeholder. And if we go to /counter, this placeholder will be replaced with the information here. This is the client-side structure. And if we focus on the server-side structure for now, it's very, very similar. The only thing that is different is that in this startup file, it has more information here. It configures the default route here, which is our host file. This is the entry. Well, the entry point is still the program.cs file, but on the front end, this page gets loaded first, which has all of the HTML structure, just like the index.html in the client side. And we also have this Blazor server.js JS file, which kind of handles the Signal R communication channel and some other tasks as well. And we also have this app component placeholder here that loads our root component, right? And the root component, basically from this point on, everything is almost the same, if it's not exactly the same. So we goes to the main layout. We load the main layout. So the app component here also configures the router, and then it loads the main layout, and the main layout also within the shared folder, we have the main layout here, and it also has the body placeholder. It's the same mechanism that it loads the routable component within it. So the opposite of routable component is unroutable, which means that a component that does not have that page, does not have this add page directive. So those components are basically kind of like controls that can be used in components, in other components. So I also wanted to draw this project structure on a whiteboard. I think it's going to be more helpful. So we have this program entry point, program.cs file entry point, and above that we have the startup class that does the dependency injection and also middleware pipeline setup. And above that, we have our either it's the host file or the index.html. So the host file is for the server-side Blazor, and index.html is for the client side. And above that, we have our root component, which set up the the routing, the client-side routing, and last but not least is our main layout component. And within the main layout, the most important part is the body placeholder, which is the placeholder for all of the other routable components. So we have C1, C2, etc., Cn, and all of these are actually will be eventually loaded into the body placeholder one by one and will be displayed to the user. And of course, we also have our unroutable components, which will be used within the routable components, and they also can be used within each other. So that's the product structure of the both the server-side Blazor as well as the WebAssembly Blazor. And since we have seen that the product structure is very, very similar, so you can actually switch between the WebAssembly Blazor and server-side Blazor. So if you want to start with the server-side Blazor because it's production ready and the WebAssembly Blazor is not production ready as of today, April 8th, 2020, then you can start with the server-side Blazor and until the client-side Blazor come out, and then you can easily switch to client-side Blazor if that's what you want to do, if that makes sense for the application and for the business. If you want to switch, I think the only thing that you other than changing a few lines of code and configure the program's startup classes a little bit differently, the only thing that you need to pay attention is to keep your components very, very thin and encapsulate the other logic in a different layer, maybe in a service layer. Also, I forgot to cover the import.razor file. This file, it has all of the namespaces, so it uses using directive to import the namespaces. So it has a lot of these. So you don't have to use the using inside each component. You can just put it under the inside the imports.razor, and this will import all of the namespaces for you, and then you can use the classes inside the namespace within the components that you want to use. You don't have to use the using in each component. So it keeps the code very clean.
Data binding for Blazor. So for any software that has a UI, the software needs to do two things. The first thing is to display information. The second thing is to manipulate the information. And we look at the data flow, right? For the first one, for display information, we have a UI and we have data. I'm just using a database symbol to represent data. So it flows from the database to the UI. Okay, so this is UI, this is data. This is UI and this is data. And the second one is data manipulation, right? So we have UI and we have data, and data flows into the UI. When you do your data manipulation on the UI, you always want to save the data back to the data source. So from this, we know that there are two kinds of ways for data flow. One is this one-way,
And second is the two-way. For data binding, these are the two ways of data binding. We have one-way data binding and two-way data binding. But why do we even need data binding? Why can't we just program without it? Yes, we can. We always need a UI. We always have a UI, regardless whether we have data binding or not. We always have a UI, and we also have a variable that represents the data, right? We have a variable, and we need a variable to be displayed on the UI. Right? So we load the data from the data source to the variable, and we need to display the variable on the UI. Right? Without data binding, we can manually find the element on the UI and set the value of the variable into the element. So we can manually populate the data onto the element. And once we we manipulate the data within the element on the screen, we can save the data directly back to the data source without even going through the variable, right? And if we want to load the data, we can load the data to the variable, and then again display directly onto the element. So this is one way we can do it, but that this is a process we wanted to avoid. So that's why we have this thing that is called data binding, right? Where we actually bind the UI element or elements to the data. So variable, actually, the variables, as if they are one, right? And there's two type of data binding. One is one-way data binding, where we only bind the data to the UI element. The other is two-way data binding. Obviously, we not only bind the variable to the element, but we also bind the UI elements to the variables. So that way, whenever we look at the variables, it always represents the UI elements on the screen. All right, so having said all of that, let's jump into the computer and look at the codes. So I created a server-side Blazor project, and this is the index page. In this region, under this region, I have a view model that is for a salesperson. This is the amount, well, maybe it's target amount or something like that, and then whether the salesperson is active, and under which locations the salesperson is active. And first of all, let's initialize the data. First of all, let's initialize the data. We need to override initialized method. And in here, we are going to create a new person. That's right. Indexed view model. And then I will have the salesperson, give it a name, and amount, locations, some default locations. All right, so I have the data initialized, and for one-way data binding, we can do very simple thing to display the salesperson's name, right? So it's as simple as doing this. It's an @ sign, and then you just put the variable here. So that's one-way data binding, right? And let's display a few things. Name and amount maybe, and you can format the data like this. So this is one-way data binding,
And if you run this code, we can see the name Alex. Let's have a line break here. Then we save it. So if we use Control F5 to run the project instead of just F5, then you will have this page. Once you make any changes, the page will detect the change from the signal R channel, and then you just do a refresh. You will see your changes reflected. So I added a line break, which for whatever reason wasn't displayed, so I'm trying to add another one. Yeah, now we can see the line break here, and we have this formatting here. These two are the one-way data binding, just to bind the variables to the front end. So to implement the two-way data binding, we need to use the bind attribute. So, for example, of course, if you want to manipulate data, right, let's say we want to manipulate the amount, then we need to bind not only from the variable to the input element, but also we need to bind the element to the variable, and for that we can use the bind command, the bind attribute. So we have bind value, and what do we want to bind? Which value do we want to bind? We want to bind the amount, right? I want to do this, and then here if we do this and we save, come over here and refresh the page, we'll see the amount here, 15,000. Okay, so we have this 15,000 here, and if we make a change, okay, and we tab out from the text box, you notice this amount is also changed accordingly. So if we change this number to 100 and tab out from the text box, this number is also changed. This means what? This means that when we're changing this and tab out, on change event, the value is passed to the variable, and then the variable, because the variable is also bound to this place, so this value is displayed here. So this is one-way data binding. This is two-way. In the case that we want to, so in the case when I want to change the underlying variable while I'm typing directly in the input box, in that case, I need to add another attribute, which is the bind value event. So that's trying to tell the Blazor framework at what event or what happens, the value is passed back to the variable. And here we want to say on input. So while we are inputting into the text box, the variables gets updated. That's what we're trying to say to the Blazor framework. So once we refresh, we can see while we're typing, the amount is passed to the underlying variables. So here I wanted to say a little bit more. So if you wanted to use bind, in this case you have to use bind event. All right, so if you wanted to use bind value, then in this case you have to use bind value. Otherwise there's going to be exception. So the next, I wanted to demonstrate checkbox. Checkbox is a type equals checkbox, and here we want to bind value. I don't have space, so here bind value to person.isActive. I also wanted to display the person active directly here, just so that we can see the changes. Okay, so we have this checkbox, but we don't know what it is. So we can have a label, and here we say is active. Give us space here. Refresh. All right. So we can see that is active is false, but when I check it, it's directly changed to true immediately. Uncheck false. So you can see the two-way data binding for checkbox. Next one, I want to go to radio buttons. For radio buttons, it will be a little bit different. Direct um, there's no direct two-way binding for radio buttons. We have to kind of create our own. So the name variable is the group. It indicates the group. So in here, we would have, so we have radio button 1 and radio button 2. Okay, so we have this. I can see it works like exclusive selection. It's within one group, but we need to add a binding to it. For that, I wanted to perhaps just add another variable here. Maybe I call it selected group, right? And at the beginning, nothing is selected, so I changed to 0. So I put 0 here, and because we don't want to select any checkbox when the screen's loaded, so we need to bind that value to the radio buttons. And to do that, we need to use the checked attribute. And here, we can use an expression here and say that if the selected group equals 1, then we check this. And here, if the selected group equals 2, then we select this one, right? So in this case, we're not selecting anyone. So after I refresh the screen, I expect to see that the radio buttons are not selected, right? Not selected by default. But if I change this to number 1 and I save and refresh the screen, refresh the page, I see that I'm expecting number 1 to be selected, which is exactly what happened. So next, we want to make changes to this radio buttons, and we want this change to be reflected in the variable selected group. How do we do that? So we can use the onClick event. So in here, we can say onClick, right? And again, with @sign and parentheses, here we can add a arrow function. We can say that when this event happens, we call this selected group function. Same thing here, equals 2. When I click on number 1, I want the selected group to change to number 1. And when I click on number 2, I want the selected group to change to number 2. Right? And here, maybe here I'll display the selected group. Refresh the screen. At the beginning, I'm expecting number 1 being written there. Yeah, and change to number 2 immediately. We see the change. Perfect. So we cover checkbox, radio buttons, and what else do we need to cover? Perhaps a drop-down list, right? So the drop-down list is simpler than radio buttons. Radio buttons is probably the
most difficult one. Here, let's bind to a selected location, right? So which I don't have a variable here. So here we're going to create a selected location variable, and we can see that our location has an ID, and we're going to bind that to ID. So I'll create a selected location ID equals 0, um, indicating that we're not binding to anything at the beginning. So I have this here, and then that's the select. And for options, we want to have a for each loop where we, location in person. Let's give it a better name. So I call it location under person locations variable. We have we want to create an option element. The value is log.id, right? And here we want to let's display the city. The dot is missing. So after that, we'll have a list of cities, but at the beginning, we want it to be no, empty. Yeah, empty. After that, it's fine. So, and we wanted to show, I wanted to show the selected location ID here. Okay, so let's refresh the screen. All right, so the beginning select location is 0, which is an empty item. And I have Toronto, Montreal, right? So when I select, you can see the ID changes, which is pretty cool. That's basically it for drop-down list. We're binding to the selected location ID, and the list of locations is kind of a one-way binding to the drop-down list, and then another way binding back is to a different variable, selected location ID. And next, perhaps we want to do a list, right? I want to show a list. So we would have an ordered list, and we're doing basically it's very similar to the drop-down list. We want to display the location in persons, locations. We want to have a list, and we want to show the city, right? And we want to still show the province state, and we want to show the country. All right, so we have that. Now come over here and refresh. Yep, we have a list. So what about a table? Table will be pretty similar, but I'll demonstrate more than that. So I have a table, and we want to be using the Bootstrap. And for here, we have a list of rows, and that we have for each. Again, we use this in persons dot locations, person dot locations, and we have as many rows as the locations. And I want to show everything for the table. And if I save it and refresh, I have a list of a table, and that's a list of countries in the table. But what if we wanted to create a table that it actually updates the underlying data? For that, what do we do? So of course, we can change this to an input. Let's use this city, for example. We change to input, and then the type is text, right? And if we do bind to bind value, if we say bind to what? Bind to
location dot city. Let's see what happens if we do this. Refresh. As you can see, it's working, right? And if we want, we can change the bind event to input. And yep, so we have it only in here as well. Pretty cool, right? So if we copy all of this to actually, let's give it a class to be form control. That looks pretty good. And let's copy this to replace both this and the country. And then we just need to change this to prov state, change this to country. And all right, there we have it. So we can change this to some other city, right? New York and New York, USA. So you can see that it's updated here, also in the drop-down list. So if we have a submit button, right, then once we submit, we can handle the submit event. And we can look at the locations, and we have all of the changes in that variable. So this is the beauty of data binding, that we don't need to manually go into each one of them to grab the data. We have the data already when we're handling the click event of a submit button.
In Blazor, front-end programming is component-based, which is in line with other front-end framework or libraries like Angular, React, Vue.js. A web page consists many components like header, sidebar, page components, or maybe some reusable components inside the page components, and footer as well. Traditionally, websites consist of pages, and reusable areas within pages are called controls, a name that comes from the desktop application programming realm. Blazor simplifies things and uses components to represent both pages and controls. To distinguish the two, let's call them page components and non-page components. So if you create a Blazor application, the default application that comes from the Visual Studio templates, it looks like this. I added a sales component here. But if we go through this, we have 4 pages here. The home, counter, fetch data, and sales. The sales one is the one that I added. So we'll go to home page, right? We can see this highlighted area is a page component. Counter, this highlighted area is also a page component. Same as this, and the sales component that I added. So which part is a reusable non-page component? It is the area that highlighted in blue. So let's jump into the computer, Visual Studio, and take a look at some demo about page component as well as non-page components. So let's add a page component first. We can see that a page component, there is a page folder already. So these components are page components except this this entry point file. All right. So to add a page component, we'll go to page, right click on page folder, and we click on new item. Select reader component, and then give it a name. Remember to make sure that the first letter is capitalized. Let's call it sales component. I always want to append component, this word, at the end of the name, just to make sure when you later create classes, for example, if you want to create sales, it does not cause a namespace conflict. So we have sales component, I'm gonna add. All right, so we have sales component here. Because the sales component is a page component, so we have to be able to navigate to the sales component. So in order to be able to navigate to the sales component, we use the page directive. And actually, before we do this, we can take a look at the other ones, right? So fetch data, we have the page directive, and /fetch data, which means that when we have the URL that says domain name /fetch data, it will go to this fetch data component. Same as the counter component. When you say /counter, it will go to the counter component. So when you want to go to our sales component, I want the URL to be /sales. Okay, so in this component, I will do nothing. And then let's make ourselves navigate to the sales component through the menu. And let's call this is the URL. This is the routing path, right? So we have the fetch data, sales, counter. So this basically means when we click on this navigation link, it goes to the counter component. Here, when you click on this link, it goes to the fetch data component. And when we click on sales, it goes to the sales component. So if you watched my video about the project structure, I've covered the project structure there. If this is a little bit confusing about the navigation link and how all of the files work together, you can go back to one of the previous episodes about project structure where I covered that part. So here I have added the navigation link here, and I've added the component, it's the sales component, and make sure that the routing path is sales, right? So then in the body part, when we input in the URL /sales, the body placeholder will display our sales component. So, okay, let's give it a try. All right, it's right here. So we click on sales component, right? And if we're not sure whether that's our component, we can add something here. Okay, so this is the sales component. Save. Else here, fresh. So we get this. This is the sales component. So this is our component. A page component is also called a routable component, which is highlighting the fact that we are able to route to the component by using the routing path here. I also want to cover routing for a page component. A page component must be routable, meaning that you have to be able to access the page component by following a URL, right? So we already talked about this a little bit, but I also wanted to point out that you can have multiple, one page component can have multiple rod, right? So if I added this and go to our page and refresh, by the way, what I did is I did Control F5, right? So that way, after you add it, you can refresh your page, and then all of the changes will be picked up. So we have salesperson, and add another rod, which is salesperson, right? So we can use both sales and salesperson to go to the same page component. However, it's only a one-to-many relationship from page to rods. It's not the other way around. Meaning that if you want to use the same rod in a different page, it's going to give you an error. For example, if I copy the salesperson rod and put it under counter, inside counter, and if I refresh here, see, it's going to tell me that the following rods are duplicate. We have two pages that have the same rods, and those two page components are sales component and counter component. So the error message is actually very informative. And the moment you remove this, it's going to work again. Fresh. All right, it starts working again. So I want to just cover a little bit about how the rodding works. When we use a page directive for each page component and provide a path to the page component, we are basically applying a rod attribute to the page class. So if you have created Web API or MVC in ASP.NET or ASP.NET Core, you know that you can use a rod attribute for a class. You can decorate a class with a rod attribute. When these components are compiled, they are turned into C# classes, and they would basically look something like this. Right? So you would have your whole component. The rod path is a root path, right? And your counter with this rod. Your fetch data was this rod, and the sales component we just created was this rod. So when the Blazor framework is loaded, it actually loads all of your component sort of in a list, right? It doesn't create a component yet, but it loads the metadata of these components into a list. It knows that you have these components, and it knows that which component has which rod. And then when you are using different URLs by inputting them into the broader address bar, or you're navigating inside by using the nav link, it's going to go through that list and look for a component that has that rod. And then it will initialize that component. And if it cannot find it, see the app component actually says water, and if it's not found, it's going to say, sorry, there's nothing at this address. And if it sees that there are two components that are the same rod, it's going to spit out an error. So for a non-page component, the purpose of having a non-page component is to encapsulate some functionalities, whether the component is reusable or not, right? We don't want to write a component with thousands of lines of code. We want to be able to encapsulate certain functionality within different components so that it's easier to manage. And if they are reusable, then it's even better. So in this case, let's create a component that tells us time. So to do that, I like to call the reusable component controls, right? But I just put them into a controls folder, although I still call them component. And then we're gonna display it right here, and we're gonna display in this format. Right, so we have this, and we know the namespace is the root namespace plus the folders. So we want to add that namespace here. So we're gonna say Blazor demo.controls. And to use that, let's say we want to use that in our newly created sales component. To reference to use the num-page component, we can just declare them as by using HTML element syntax. So we're pretending the component that we have is a HTML element. And so in here, and that's all we need to do. So I would add two of them. Then we go to our page here, do a refresh. All right, so we have our date time here. Today is May 3rd, Sunday, Toronto, Ontario, Canada. All right, so we covered page component, we covered num-page component. As you have noticed that our num-page component does not require a page directive, right? Another thing I want to also mention is that you can also use a page component as a reusable num-page component. For example, I want to show the counter right inside the sales component. So what do? I just declare it here. It's very easy. I just say counter, right? And that's it. And let's go to here, the refresh. All right, so we have, as you can see, if I go to counter, I see the counter component. If I go to sales, I also see the counter component, and it works. Okay, now let's cover component structure. A component has basically two areas. One is the HTML markup, and the other part is the C# code blocks, right? You can have more than one of this. You can have, two. It still works, right? So you can separate them. So this part covers some functionality, and this part can cover different functionality. You can use this to do it. So the HTML markups, obviously, it defines the look and feel. And the C# code blocks, it contains UI logic. So let's take a look. I have no logic here. Let's take a look at the counters, right? So here it displays some dynamic information. This is the title. So these are all for look and feel, right? And here defines a button. And then when the button is clicked, we increment the the variable. So when we combine the C# code blocks along with the HTML markup together, they dynamically render the component. Now let's talk about component inheritance. So let's say that all of our components have a common property. And let's just say that property is called date, right? It's because all of our components want to be able to display date. So in that case, what do? Do we declare a date variable inside all of our components? So that would be code duplications, and we don't want that. So what we can do is, of course, yeah, we did this way. But if we want to use that date variable, not only for display, but also for some other logic process, then we have to be able to reference that variable inside each one of the components. So how do we do that? We don't want to create a variable inside each component. We want to be able to inherit it from a base component. Blazor supports inheritance. So let's create a base component. It's basically a C# class. Maybe let's call it datetime. Base component. And what do we have here is basically a property that is a date time, and let's call it datetime. So another thing that we need to make sure that our component need to derive from component base, and if I do control dot, it will generate that using statement there. And now let's use this base component. Let's go to our sales component, and in here we want this page to derive, this page component to derive from our datetime base component, which we have to actually do the using statement here. We don't have to do it in the imports.reader. We can do it directly in here, but because I did it, so we can access the class name directly here. So we are inheriting from, we make the sales component inherit from the datetime base component. And let's delete these confusing lines, and let's just use the, let's just display the datetime variable right here, right? And in order to make sure that we have it, I put the date label here. All right, so as we can see, we have this right here. Well, it doesn't have, it's the value was not initialized, so it would be the minimum date time here. Blazor programming is component based, as was covered in the previous episode. And you would have page components and non-page components, right? So for example, you would have page 1, page 2, page 3, page n. Each page may deserve to have subcomponents, and those components are non-page components. For example, this page 1 has 2 subcomponents, and page 2 does not have any subcomponents or non-page components, and page 3 is even more complicated. It has, you know, a component tree like this, and page M may have something like that. So now the interesting thing happens. So now when we have a complicated structure like this, what needs to happen is a communication between these components. And the communications between the page components, this kind of communications, are done by passing routing parameters. And the communications between the parents and child, this is done by parameters, regular parameters, routing parameters, and this is also routing parameters, but these ones are regular parameters. Okay, so this is also, and this is also, right? So these are regular parameters. So we have routing parameters, and we have regular parameters. And the third type of parameters are cascading value parameters. So in that case, we have a deeper tree structure like page 3, and sometimes we want to pass the value down from the parent, from the page component, all the way to the leaf, right? All the way to all of them. And we can do that by using the regular parameters, right? All of that can be done, but Blazor has a better way to do that, and it's called cascading parameters. I'm not sure whether I'm spelling correctly or not. So another type of communication is that when the children are trying to tell the parents about some interesting that happens, right? For example, your child calls you from university about something, right? And you would have to react to it. So that kind of is called event callback, that kind of communication. So this is event callback, right? These blue ones are event callbacks. And another type of communication is when you want to tell your child about something, right? When you call your child about something interesting happened, and you ask your child to do something, and that kind of communication is when the parents calls the child. This type of thing, we reference the child component, and then we can call a method on that child component directly. What you're looking at is a standard Visual Studio template for Blazor server-side application. I added a few components, but today we're going to look at the sales component, which is empty, and the order entry component, which is currently also empty. And in order to see them, they're both page components, and as you can see, I give them different route. And the order entry component uses the order /order route, and the sales component uses /sales route. And in order to see them, we are going to add the navigation links. Copy 2 of them, and then this, I'm going to call it sales, and this, I'm going to call it order entry. And I'm going to change the route to sales, and this is going to be order. And if we go back here and refresh, we're going to see sales and order entry. And what these two represent are, the sales represents sales department, and the order entry represents the order entry department. Both of them are page components. So as you can see, if you have many departments, you might want to consider having this title part as a component by itself, right? So let's do that. Let's create a non-page component, and as you know, I have a habit of calling it controls, but you don't have to call it controls. And I'm gonna create a new component, razor component, and call it title component. And this is a non-page component, so it doesn't have a rot. But what we are gonna put here is we're going to go to the page component and copy one of them. It's basically this, right? And we're gonna come over here, and then we're gonna say, welcome to the, and we're gonna change this part dynamically, right? So we're gonna give it, a variable here in order to populate that. But it's not just any variable, it cannot be private a variable, because this variable has to be available to the parent component. So it has to be public. And in order to allow the parent component to access this variable, it has to be a special variable, and it has to be a property, and it has to be a public property, and we call it, we can call it department, right? And here we have to use a parameter attribute to let Blazor know that this property department is a public parameter that can be accessed from the consumer, which is the parent component, right? And then we can use this over here, or actually over here, and we can say department, right? And then when we use that component in the parent component, we can do this as I have shown in the previous episode. We can use the child component as in order to do that, I'm going to import the namespace, and then I'm going to come over here and I'm going to type in title component, which is right here. And as you can see, the parameter is right here, right? And then in this case, it is sales, right? I'm going to copy this code, and I'm going to go over to order entry department, and I'm going to call it order entry. This way, when we go to our code and hit refresh, we're going to have the sales and order entry department represented by our one component, our title component. And the good thing about that is if you want to change the wording or the style or the theme or whatever of the title, you can change it from one place, right? So we can go to our title component, and if we want to add, for example, we want it to be underscored, we can have this, and then when we go back, refresh, as you can see, the underscore is right there, right? If we want to change the font color to, we actually change to header. If we wanted to change the font color to blue, dark blue, then we can change it to dark blue like this, and then we go back and we refresh. There we have it. Changing in one place, passing in parameters. So to sum up, in order to pass a parameter from the parent component to the child component, we need to create a public property and decorate it with parameter attribute. and then we use our component, child component, in the parent by declaration, and populate the parameter with the value that you want to use. So the ROT parameters are used to help us communicate between page components as well as between non-page components and page components. To demonstrate, I created Teams component and team component. Right? The Teams component is a list of teams, and the team component is the detail of that team and also showing the member of that team. And in order to display them, because currently we don't see it on the menu, so in order to display them, I am going to also add the navigation menu, just like last time, but make sure we have proper route. When we come to the navigation menu, we clean up this a little bit. We change this to Teams, and we change this to Teams. As once we refresh the page, we can go to our Teams, and we see a list of teams. And for now, let's take a look at the codes that I had. So I basically have a Teams variable here, and I initialize the variable and populate hard-coded some values here, and I created this team class here. Usually all of these should be created separately as models, and dependency injection into the Razor components, but since I haven't covered dependency injection, so I'm hard-coding these over here. What my expected behavior is that when we click on any of these teams, we go to the team component, the team page component, and display the detailed information about that particular team that you clicked on. Our code here, our markups, HTML markups, we can see that I used for each loop and created the rows within the tables, and it's displaying team and team region, and also I have a anchor element here going to the team page component. So when I click on it, it goes to the team component. Unfortunately, every single one of them go to the team component. The team component is empty, right? So let's go to our team component over here. And it has pre-populated some codes, but it does nothing. As I said, that these should be created as models and dependency injection into the Razor components, but I'm just hard coding it right now. So don't worry too much about them. So I want to display the detailed information about the team as well as the members. So I have these data here to kind of represent the member database table. Right, so you'd have a list of members, and you know the IDs of them, and you also should have the team ID, right, to indicate which team the member belong to. So for that, I'm gonna create a team ID property, and then I'm going to go over here and populate that property. Team ID equals 1, and I'm going to let them to become different teams. All right, so but the thing is, how do we pass that information about which team we have selected? That's where the ROT parameters come into the picture. So in order to do that, so here we can say that basically here we can say /team. And then we give the team dot the ID slash. All right, so that gives the proper raw parameter here. So if we go back here, we can see that at the bottom left corner, you can see each one of them has a team ID appended at the URL, right? But the thing is, when you click on it, it's gonna say there's nothing at this address, right? So we have to change our team component to accept that parameter. And to do that, it's actually pretty easy. We come over here and we say, I'm expecting an ID parameter. And then we come over here and we create a corresponding property and we call it ID, right? And within here, you can say parameter, and this corresponds to the ID, right? And let's see what happens when we do this. All right. Refresh, click on it. All right, so we have received a exception. And so what is happening? Let's take a look at the developer tool. So it's complaining that unable to set property ID on the object of team component. The error was unable to cast object type string to integer. Okay, so that is telling us that it's considered as a string, but we are expecting an integer. So what do we do in that case? We set up a constraint here. We're saying, okay, I'm expecting integer, right? So another way to do it is that we can change this to integer. Sorry, change this from integer to string. So let's do that. And then we refresh. All right, so now we're going to the team component, but we are not loading any data yet. At least we're passing that property, right? We can say, over here, we passing that ID. Let's display that ID. Refresh the page, okay? Yeah, we're properly passing in the ID from the teams page to the team page. So that's the communication between different pages, right? So in order to properly display the page, we can come over here and we can say that, I'm searching through the, we can use link to query the teams variable that I have it here. We can say that if the ID equals this.id, which is our parameter, raw parameter, then that's the team that we are looking for, right? And it gives an error here, right? Because this is a string and this by itself is an integer, right? This is integer, so it doesn't want to do that. So let's change it to integer, and then we will add the parameter constraint, and we're telling Blazor that this parameter is an integer, right? So now this is fine. So we will have our team. So once we have our team, we come over here and we say that the the name is team dot name. The IntelliSense is not great yet. It seems that it's a little bit slow. So here we can have region, right? And let's see whether that works or not. So I saved and then I refresh. Okay, let's go to red team. So we have red team here properly. The parameters properly passed in, and our link query is also working. Okay, cool. All right, next is that we're trying to display the members, right? We're going to create another place here, and then we are going to find our members first, which is we have it here, and we need to find all of the members. So the members are from the members. I want to find the members who belong to the team. So team ID equals this.id, which this ID again is the parameter value, the raw parameter value. So then we would have all of the members, right? So we have our members here, and then we come over here and we say for each, so here we want to display it in a list to save some time instead of displaying in a table. And here we're gonna have for each, and we're gonna have variable member in this dot members, and here we're gonna say li, and we're gonna say member dot name. Well, pipeline member dot age, IntelliSense. What else do we have? Yeah, name and age. Yeah, that's good. And then let's see when we refresh our page. So go to our red team. We have team name is red, region is region 1, and John's age is 20, Mike's age is 25. Going back to teams, go to blue team, and we have Joe 26, Ross 21. And yellow, we have Ryan 23 and Fox 22. So there we go. We have parameters passed in as raw parameters, and going to the different page from from teams page to team page, and we successfully load data and display data based on the passing raw parameters. Let's talk about cascading parameter. So if we have a component tree like this, where you have the page component that contains several levels of component. So these components make the tree a little bit complicated. So in this case, if we want to pass a parameter value from the first level, from the page level, down to the leaf, if we want to use the regular parameter, we have to pass the parameters as many times as the number of levels that the component tree has. So one way that Microsoft has came up with to solve this problem is they created something that is called cascading parameter. It's something that you can use to cascade a value from whichever level downward to the lower level components. You don't have to cascade one by one. Okay, let's jump to the computer and see how it's implemented. All right, and this is a standard template, Blazor template. It comes from Microsoft. And we go to the counter page. You can see when we click on it, the current count increases. So we're going to modify this to mimic a scenario where we have many levels of components. We're going to create another 2 level. So altogether we have 3 levels. So this is the counter component. Let's create 2 more components. Let's create 2 more components. Let's call it component 1 and component 2. And in order to distinguish them, I'm going to add some CSS style. So we're going to add some margin to component 1. And then I'm going to add another margin to component 2, which we'll cause some indentation so that we can see the different levels. So with this, we are, instead of displaying the current count inside the counter component, we are going to remove this. And we are going to display the counter count in the component number 2, right? But before we do that, we are going to add the components in. We have component 1, and then within component 1, we add component 2, right? So component 1 contains component 2, and counter component contains component 1, right? So if we refresh our page, right, so we're gonna see component 1 and component 2 like this with the margin indicating the different levels of components. So now I want to display the counter value inside component 2, right? How do we do that? We need to wrap our components with a cascading value element, and we're gonna tell Blazor that this value is called counter, and the value itself comes from the current count, and we wrap this component 1 with it. So current count is here. So what happens is that when we click on the button, it calls this event handler and it increases the count. And this current count is passed into the component tree. No matter how deep the tree is, how many levels the tree has, you can access this count value from within the components. So let's say you want to access from component 2. You can actually access from component 1 or component 2 or both, right? So in this video, let's directly go to component 2, and we're trying to display the count here, right? So let's say I want to tell that the count is the counter value, right? And to do that, we need to declare a parameter, and that is the same type. And the name can be any name. Let's call it counter value. But we have to decorate it with this cascading parameter, and we tell it name of this cascading parameter is counter, right? That's the same name that we give it here, right? So you can name your cascading parameter with anything, but then as long as you declare that in the attribute part, that you make sure that this counter value name is the same with the name that you declared inside the cascading value element, right? So now with this setup, you would be able to rate this counter value directly from the counter component, the parent component, the ancestor component, right? It will contain this value. So let's see whether we'll get the correct value. So we're going to display this value right here, counter value. And then we're going to go back and refresh our page. All right. So now it shows counter value 0. And then we can increase. When we increase this, it goes up. Okay, so we have successfully passed down the counter value. So this helps us a lot when we want to pass values around the component tree. It's very convenient. One of the disadvantages of this is that when you need to pass the values around all of the components in the component tree, the Blazor framework would have to monitor all of the components. you just one cascading value that you want to cascade, then Blazor would have to monitor all of the components if you want to pass the value to all of the components. For example, about a theme of your application. Once you set it, it has to be accessed by all of the components, and the component, each one of the component will monitor the change of that theme. Once it changes, then every one of the component will change. So this kind of makes the Blazor framework have too much to handle, right? If you have just one variable to cascade, it adds a lot of work. And then you have 2, then it has more work. It has 3, then it has even more work. So by the way, let's see how we want to cascade multiple parameters. How do we do that? Okay, so let's do that first, and then we'll come back to the drawback, to the to one of the problem was this, and how we can fix this, kind of a performance issue, right? Because when Blazor has too much to monitor, it takes too much resources, and it causes performance issues, especially with Blazor server side, that it monitors, each user has his own session, and it hosts the session state and everything. So that's if you give it more work with the cascading parameters, it's going to create more performance issues. So we're going to come back in a minute. Let's see how we can implement multiple cascading parameters. So let's go to counter, and let's just cascade. Let's say we want to change the color of that. So we would add another level of cascading parameter, and we call it, let's say title color, and the value is, I'm gonna directly give it a value right here. Let's say the value is blue, right? And now we can go to our component, child component. We can declare another cascading parameter, and making sure that the title matches. And here it doesn't matter, we'll just call it color. And then we are going to modify the color, right? We call it call this color value here. And if we refresh, we're expecting the level 2 component, the component 2 becomes blue. Refreshing, it's not blue. And why is that? Title counter. Title color. Oh. Title color. Alright, so it's blue. Alright, so we're actually cascading multiple levels. Multiple cascading parameters, multiple values. So let's go back to the point that I was trying to make about the performance issue. So, and this is actually a good example that we are cascading a color down to the component 2, right? But it's static. Means that it's not changing like the count value. It increases or decreases. It's static. It's fixed. So, but even though it's fixed, because we have declared the cascading parameter here, Blazor framework will still try to monitor this and try to see whether this color will change, but it's actually not going to change. But this is actually, it takes resource from Blazor framework, right? So it will actually impact the performance. So one way we can avoid this is to come over here and say, this is a fixed. This is a fixed value. So when we go back and refresh, it's not going to affect it. It's going to still work. You're not going to see any differences, but it's going to avoid the performance impact. So this is what you need to do when you need to cascade a fixed parameter. For example, if you have different departments, right? You have order department, you have sales department, you have different departments. And if each department has its own page component, and each page component has its own complicated component tree, but inside the two component trees, you want those child components to know about which page component you're in. I'm in the order department component tree, or I'm in the sales department component tree. I want to know the department, right? So this type of value, although it changes when you click on, when you navigate to the page component, but it will, once you are there, it never changes. So in this case, you should use the isFixed equals to true to tell Blazor framework that the value of the cascading parameter will never change. So this will not impact the performance, will not affect the performance. So that's something we need to pay attention to. Another thing we need to know about is that cascading parameter, you can only cascade down. You cannot pass the value upward. So one way to resolve that issue is to add some event callback or add a delegate parameter, basically a regular component parameter that is declared as a delegate, and then from the parent we register to the delegate, and when you click on the button, you trigger that delegate. Basically, you trigger the function inside a parent component, and then your parent component react to that, handles that delegate, and increases the counter, increases the variable defined in the parent component. So that's one way to do it. But if you have many levels, you have to declare that delegate parameter for many levels, up to the top components, right? And that's a pretty, in my opinion, that's not a very good way to do it. If we go down that route, I would suggest to use a centralized state management, which I'm going to cover in later episodes. So that's the other thing the other point that I want to make, which is that we cannot pass parameters up the component tree. Another thing that we really need to pay attention when we use cascading parameter is that it can quickly become pretty messy, right? So when you have a complicated component tree like this, you can have the cascade. You can declare that cascading parameter, cascading value element on any levels, and then on any lower levels, you can receive that with different names. And if you come over here, for example, you click on this and you say, okay, I want to know where this value come from, right? So you can't right click and go definition because it will not go anywhere, right? This is defined right here. You click on it, you can follow it. You don't know where it's defined, right? So when you have many levels, so this is not as many levels as, this is not too complicated, but when you have many levels, when you have very big trees, you don't even know where it's defined, right? And you have to use search in your IDE to find it, in your Visual Studio to find it, which is not as pleasant. It can quickly become pretty messy. So again, in those cases where you want to use, when you find yourself declaring a lot of cascading parameter values, cascading parameters, that's probably a sign to tell you that you should use a centralized state management system instead of using the cascading parameters. So we should really use the cascading parameters sparingly. Event callbacks are for communication between parent and child components. And it's when the child components has something interesting happens, then it basically calls their parents and say, hey parent, I have something interesting happen. Please react to it. Let's take the counter component as example. Let's run the default application. Go to counter components, click me, then it increases the value. And if we change it a little bit so that the counter component becomes a subcomponent, then we can demonstrate the event callback. So let's create another component. Let's call it parent component. And let this parent component to use the same route. Of course, we have to remove this route so we can make the counter component itself becomes a subcomponent because it becomes a child component of this parent component, and we use it like this. And if we run this code, refresh right here, it's basically gonna do the same thing, except you're gonna see a title here is parent component, because now the counter component becomes a subcomponent, becomes a child component, and it will work the same way. But what if we want this current count to be displayed inside the parent component instead of under the counter component itself? So for that, we can remove this. And then we come over to the parent component and we declare a variable here, and we call it private integer current count. Right. So, and then go back to counter component, and and then here we declare a public property, right? And we have to make sure that it's an event callback, right? And with a parameter, and the parameter value is parameter type is integer, and we call this set current count, and this has to be a parameter. And then we are going to invoke this set current count under the event handler of the increment count, right? So basically we're going to say invoke async, and it's current count. Then we're going to come over here and refresh the screen, and then of course we didn't hook it up yet, but let's try that. Okay, and we are not seeing any exceptions, so keep that in mind. Then we'll come back and talk about that. So in order to implement this, we need to go back to the parent component, and then we're basically come over here and set the parameter, the set current count, as a, basically you can just say set current count, and then in here we're gonna have this set current count with integer value, and then we are going to say current count equals value. And what we're going to do is we're going to display this current count right here. current count. Then we're going back over here, refresh. All right, so current count initial is 0, initial value is 0, and then we click on it. Now it works. All right, so coming back and just to summarize that. So first of all you need to do is that you need to create a parameter that has a special return value, which is a event callback. This type is event callback. There's two versions of this. This first version is without the generic type. The second version is with the generic type. Depends on whether you want to pass a parameter to it or not. So this is basically the parameter type of this set current count. Right? So when you invoke it, this current count parameter has to be this type, integer type in this case. The second step, so once you declare the parameter like this, then you go to your parent account, and then you basically set the parameter just as any other parameters, except that this is a function name instead of just a value. Right? It corresponds to this. You can call it any function name, it doesn't matter. It doesn't have to be the same as the parameter name. And if we refresh the screen, you're going to see it's going to work anyways. It doesn't have to be exactly the same. Right, so those are the two things, two basic things we need to know about it. And then we just dig a little bit deeper into this event callback. So the event callback is not just any parameter. It has a special type. And this makes us kind of think that it's similar to a delegate in C#, right? But it is very similar to a delegate, but it's not exactly the same as a delegate. For example, you don't have to, when you invoke it, you don't have to test whether it's empty or not. Right? It's not going to throw an exception if it's empty, right? We have seen that. So let's try that again. If we remove this, which means that we are not actually providing any registration to that delegate. If we call it delegate. It's not even a delegate, but we refresh this. It's not throwing any exceptions, right? It just doesn't work anymore, right? So let's put that back. So coming back over here. So it's not a delegate that you have to check whether it's registered or not. You can just directly invoke it and it's going to work. Secondly, it's different from a delegate because we can actually declare a delegate right now, right? So we can declare a delegate like this, and basically we can do the same thing. We can simulate this with set count. Let's call it set count, and then over here we can declare this as a parameter as well. And then when we go to the parent component, we can give that delegate assigned to the same function, right? And then if we remove this, and then we'll go to the counter component, and instead of calling this, we just call setCount dot invoke. We pass in the current count, right? Let's see whether it works or not. Okay. If it works, then there's no difference between a delegate and the event callback. You see, it doesn't work. I'm clicking on the click me button, but it doesn't work. Why? Because your parent component, you're basically triggering this event from a child component and expecting your parent component to re-render, right? But it doesn't re-render. The value is set, but it doesn't re-render. And the reason is that your component does not render if the event is triggered from other components, unless you specifically say that you want to re-render it. But if we are using a event callback, then whichever function that is connected or assigned to that event callback, your parent component is going to watch that. And once that function is called, it's going to re-render the component. But in order to make this work, we have to say, hey, state has changed, right? Because this function is currently assigned to the setCount delegate. And the setCount delegate, when the setCount delegate invokes, this function is not going to trigger a render unless we're specifically saying that we know the state has changed and go ahead to re-render. And now let's see what happens, right? So now it works. So that's why it's different. And another thing that we can try is that if we remove this and see what happens. If we remove this and then we click on it, immediately we're going to see and handout exception has occurred. See the browser DevTools for details. Why? Let's see the browser tools, and then at the bottom, the console. Actually, let's look at the console here. It says null reference. Why? Let's go back and take a look at our child component where we invoking the delegate without having the delegate assigned to a actual function, right? So there's no registration to that delegate. So we can just invoke like this. But for event callback, we're okay. We can just call it whether there is a registration to this event callback or not, right? So going back here and set current count equals, well, if we don't set anything, refresh again, right? It doesn't work, but it doesn't cause any problems. So that's the difference. Sometimes from the parent component, we want to directly invoke the methods or properties of the child components outside of the declaration. Right? So, for example, some event happened, you want to trigger some other things under your child component. Let's take example very quickly. Let's create a child component. Actually, it's going to be a control. So let's create a folder and call it controls. And then under here, let's create a new Razor component. Just call it child component. We are going to be displaying the child component under the counter component. And let's have a line break here, and then let's call the child component right here. Right here. Well, that's ugly. Let's import our namespace right here. Let's Blazor 3 dot controls. So, and then we go back and delete this, and we call it child component. And now if we refresh the screen, we'll see our child component right there and under here. And what we want to do is that we only want to display the child component when we click on the button. Right, so do the extra line break, and then we're gonna have a button, and we're gonna have. And now we want to, when we click on the button, we want to display it. So basically means that we are not going to display whatever markup that we have at the beginning. So we're going to declare a member here, and then says it's a boolean, and I'm gonna say and call it display, and we are only gonna display this if it's true, right? So we're gonna put this right here, and then we go back, and this button, we'll complete that button later. So if we refresh, then we don't see that. We see this empty button here, but that's okay. So the important thing is that we're not seeing that child component anymore. So we want to click on the button and to show the child component. And over here, we're gonna say onClick, and what we want to do is we want to display the child component. We are gonna say here, how do we set the display variable under the child component? That's where the referencing child component come into place. So how to do that is that we say reference, and we say, child, and then over here we create a attribute, and we say, child component and child. So this name and this, they have to be the same, and then we can use this to reference the child component. So we can inside here, right, we can say child dot something, right? So what do? We go to the child component and we create a public method. We say show, and then we just say, display equals true. And then going back to the counter component, and then we say child. So when we click that button, we reference the child. We say show yourself, my child. Right? So go back and refresh. Now we're gonna see that button. This button is using BOMA. So I do have BOMA here, and this button is controlled by BOMA. It's using a BOMA class, but I haven't referenced the BOMA under the host. You can see that I have this, but I don't have BOMA, right? So as soon as I reference BOMA, then it's going to be displayed. Yeah, it's gonna take effect. Refresh again. All right, that's BOMA style, and I like BOMA much better. So in future demos, I'm going to use BOMA for developing components. Actually today as well. So now you can see that we are not seeing that child component, but if I click on it, it's going to trigger that child component show method and set it to true. So the child component is going to show itself. Okay, so the reason why the child component is not showing, again, we talked about this in the previous episode. That's because the component will only render itself under four different conditions. First is when the component is created. It's just created. Secondly, it's when parameter value changes. Thirdly, when there's event handlers. For example, you click on a button, and then under that event handler, you change the state of the component, and that component is going to re-render itself. And fourthly, that's when the developer want to re-render the component by calling the state has changed method. So because we didn't call the state has changed method, and because we are calling the show method from outside of the component or within the component, right? If you had a button right in the child component, and then you trigger the show method, and then you change the property, you change the state of the child component, then the child component will be re-rendered. But in this case, we have to specifically, as a developer, we have to specifically call the state has changed, and then it will re-render itself. So let's refresh. You see, when I click on it, child component shows, right? So go back. Every time we navigate to a component, it's recreated. So now you don't see the child component, but when I click on it, now it shows. All right, so let's have an even better example. Let's create a dialog with BOMA style, and then we kind of toggle it, right? So let's go to BOMA, and let's go to BOMA model dialog, and let's go to model, and what I want is this model card, and it looks like this, and it's pretty clean. And in order to show the model dialog, you can see that in order to activate the model, just add isActive modifier to the model container, right? So we're gonna copy this, and then we are going to create another component. We're gonna call it dialog component, right? And then over here, we're gonna remove this and have this over here. We're gonna actually add this is active right there, but we are not gonna change the class. What we're gonna do is we're gonna have again the same sort of thing. We're gonna have this, and we're gonna initialize it with false, and you're gonna get over here and say, hey, if the display is true, then we display, otherwise we're not gonna display anything, right? So go over to counter and remove child component. We are going to say we're going to add the dialog component right here, and we want to reference the dialog component by using the name dialog, and over here we're going to say dialog component dialog, and we're going to trigger this right here, but it doesn't have the show method yet. Let's go to our dialog and create a show method, public void show this display equals true, and we can also have our close method right over here and call this display equals false. And another thing is that here's a button. You see this button? It's a close button, and we also need to make sure that we close this as well. And we're gonna call onClick, right? And again, we're gonna have our we're gonna call this, and we're gonna say close. We're gonna call the close method that we just created, and we know that this is not gonna work because we have to say state has changed, right? And we get over here and call this as well. Now we go to the counter component, we refresh it. Actually, we should change the name to show dialog. Go to counter, and we change the name to show dialog, and coming back, refresh again, and then we click on it. We see the dialog, right? Well, it's not doing anything, but we click on this button. Yes, it closed. So going back to dialog component and get over here, and we also call this let's just to make it simple, we just call close like this. right? And of course, on these event handlers, we should actually do more than just closing, but for today's demo, we just only call the close method, and that's everything we do for today. Let's go back and refresh the screen. All right, so we have this, and these buttons work as well as the close button. This is the documentation from Microsoft regarding the templated component. And there are three key factors within a templated component. The first one is RenderFragment, right? This type of parameter. The second one is a parameter that is a generic type list. And the third one is a RenderFragment with a generic type, with the same generic type. So the three of them, they don't need to exist in the templated component in order to make it work. So today, I'm going to only talk about the RenderFragment. And then future videos are going to cover the other two. This is the Visual Studio server-side template from Visual Studio. It's just nothing new, and let's build it and run it. And as you can see, it's just the default template of Blazor server-side. And let's talk about what is the purpose of having a templated component. In my opinion, templated component gives the developers the ability to provide some sort of template to the component itself. And the component also provides some sort of layout, right? So this is more on the UI side. The functionality is mostly on the consumer side, right? So the consumer of the component, which is the parent of the component, are going to provide more functionalities, and the component itself provides more layout, right? So let's take an example that uses the RenderFragment, right? So the RenderFragment itself is it's used as a type of a parameter, right? And this parameter is basically when you use it, it's going to be a wrapper of some HTML. Let's have an example so that it's easier to explain. So let's take a look at BOMA, right? So for BOMA to have this field, what it needs to do is to have this much HTML. So if I copy this and paste it over to our, let's create a component. Actually, let's just use it on the counter. Actually, use it on the index, right? And delete this survey control and paste it over here. We need our BOMA CSS, which is not in here. So I'm going to copy this over to Blazor 4. And then we're going to go to our host and copy this. Right. And that's it. All right, so we have our BOMA in here, and this is going to work, I believe. All right, so let's go to this Blazor 4 and refresh. It's the home control, right? So you see this, right? But if we go back and we look at this, well, yeah. So this is, it looks pretty good, right? It looks pretty neat. The style is what we like. But then what's going to happen when you have many views on the form? So you have to kind of copy paste and this whole thing, right? So suppose we have name is over here, so we have name, we have title, and we have department, right? So for only 3 fields, look how many lines of HTML from line number 9 to line number 44. So it's getting crowded with just 3 fields, right? So what can we do to make this the number of lines of HTML shorter, more compact? So we can actually make a component by utilizing the render fragment, right? So let's do that. Let's create a component, and I want to create a controls folder and create a component under the control folder. So let's go over here and go to component, and then let's call this build component, right? So, and then what we need is this. Let's copy and paste it over here and see how we can make it easier. So we need to provide a name of the label, right? So that means we need a parameter and a public property with a string type, and that's let's call that label name, or let's just call it label, okay? And we also need input to be somehow in there, but this input, it cannot be inside the field component, because it may not be just an input control. It can be maybe a radio button, right? So you don't know the type. It's better to be provided from outside. And here is why we need to use a render fragment, right? So we can take this out, and then we create a special parameter. We call it so it's going to be also a property, and this has to be render fragment. Okay, and today we are not going to cover the one with the generic type. So, and here it's going to be called, let's call it control. Okay, and what we can do here is that we render this render fragment right over here. Right? When we do this, Blazor framework will recognize that this control is a render fragment. Therefore, it's going to render the HTML that the consumer or the parent control provides to the child control. Okay, so with this, right, what we can do, instead of having these number lines of code, we can have it way shorter. Oops, sorry. We can go over here, and we can use our field. Actually, let's import that namespace so that we can see it. Get over here, and then if we enter again, you can see we have that, and then we provide the label, and we call it name, right? We do the 3 fields, and then what we can do here is supposed to be, okay, so it's the IntelliSense is not working very well. So here we have this, right? In control, inside here we can have this input, right, and placeholder. Well, of course, this is name. And then we copy this 3 times, and this is gonna be title, right? Title, and this is department, right? And look, we completed the 3 fields with only about a little bit more than 10 lines of HTML, right? So let's delete all of these. We don't need them anymore. And let's go back. Oh, All right, so we forgot to change. Oh, we forgot to add the label here. So it's label, right? Going back, refresh. Okay, cool. So we have this. All right, so we just learned how to use the render fragment by creating a field component, right? And this field component can be used everywhere else whenever you want to create a field. And let's just summarize what we need to do in order to use the render fragment so that the developer can provide a template for your component to use, right? So it's actually pretty easy. You create a component, right? And you create a special parameter that the type of the parameter is render fragment. And then you use this in the HTML markup place where you want to render that template. And then when you use it as a child component from a parent component, you just declare it as HTML and then use that render fragment parameter as a HTML. Instead of use it as a parameter like label, you use it as HTML, right? And then within that wrapper with the render fragment, provide you actual HTML. Then Blazor is going to render this HTML inside here to replace the render fragment parameter. I want to cover the second key factor of the templated component, which is the generic typed list of items. The purpose of this items is to provide a list of items for the generic type render fragment to use. But is that the only purpose? Can it be used for any other purposes? Today, we're going to talk about using the generic typed items by itself. We're going to learn that by creating a automatic rendered grid. Let's call it auto grid. The way I do it is that I'm not going to have the render fragment. I'm only going to have this items, and then I'm going to use reflection to create a automatically generated grid. Okay, let's jump into all right, so let's create a control component. Let's call it grid automatic grid. All right, so don't need the title. First, we need a parameter. Let's create this type param. Right, this is the type of this is the generic type of this list. Right, and this we would call it items. So instead of using the render fragment with this items, we can use this item by itself. So how do we do that? Right, so we need to use reflection in C#. We need to see all of the properties of this item itself before the component is rendered. And there is a event in the event lifecycle that is called onParameterSet. And that function, that method is called when the parameters are set and before the component is rendered. So let's override that onParameterSet event. If the items is not now and items count is greater than 0, then this is the place where we use reflection, right? Type of item, use reflection to analyze what kind of parameters, what kind of properties the item has, right? And the type has a getMembers method, which is gonna give us some information about our right. So this member info we need to include. We need to use the system.reflection namespace. Reflection. And okay, so now we have this. So we got the member info, and we can do this. All right. So this member info has the information about of all of the members, including like constructors, methods, properties, and all those stuff, right? So and then we can use this to in our markup. So in our markup, we want to render a table, right? So the grid is like a table, right? So this is like we only render the table if the member information has value. Like this, and we're gonna render a table, and we're gonna call it. We're gonna use the table class, and let's first render the header, right? And it's gonna have a list of columns, and that list of columns corresponds to the properties. We're gonna loop through the list of members, right? You know, this member has a member type property, and this indicates whether it's a constructor or it's a property or it's a method. So we will only create a column for the members that are properties. So if member.memberType equals memberTypes dot, see we have property field method, this is type and all these stuff, constructor, so event. So we will only render if it's property, right? And then in this case, we render member.name. And we're gonna use it in our index, the home page. Here we need to feed some data to it, right? So I have prepared some data. So we have this. First, we declare a class. It can be any class, and then I'm gonna override the uninitialize EventCallBack, and I don't know whether. And in here, we're going to initialize that. Actually, we're going to have a list, right? And then in here, we're going to create a list of employees. Let's just call it employees, okay? Initialize this list of employees. So we have this list of employees, and we want to provide this to the grid component, right? Because we already have this items items parameter inside the grid component. So now we are going to call the grid auto component, and we know that there's a parameter that is items, and we are going to provide employees list to it. And let's see when we run it what it looks like. Okay, so we see this ID, name, title, department, right? And now we go back to our grid component and complete the rest of the markup. So in the body, we're gonna get the value of each property, right? So in here, we are going to say, for each item in this items, Right, so it's going to have as many rows as the number of items. So we're going to create a row under here, and then we're going to loop through basically the same thing. Going to loop through the properties, and then we got the value of each property, right? So in here, instead of th, it's going to be td, and we are going to call item get type get property, and then which property is this property, providing the name of that property, and then there is a method get value, and so it's for this item. So I believe this is it, and let's go back and refresh. All right, so we have our automatic grid. So this is great, but I don't want to show the ID, right? I don't want to show certain columns. So what do I do? Okay, so we can create another property here, parameter here, and let's call it columns to exclude, and it's going to be a CSV. And how do we use this? So if this contains, so I guess it's going to be in here, and then we're going to say that if it's a property and if the name sorry, no, it's not, it's the other way around. It's if the columns contains, if it doesn't contain, and it's going to be case insensitive and negation. So if it doesn't contain the columns to exclude, then we're going to render it, right? So the same logic would be also applied to here, right? And going back to our place, then we can provide that extra parameter, that columns to exclude, and can call it ID, right? And in this case, I think it's going to work. Let's refresh. All right, so we don't have the ID column, and if we don't want the name column, well, that's probably not a good idea. Let's see. If we don't want the department column, we can add the department column, and then we refresh. You notice the department column is going to be gone. All right, cool. Okay, and I like the department column, so let's put it back. Another thing is that we are using BOMA, right? And for BOMA table, it has different kinds of classes to modify the appearance. So let's do a search. BOMA table, and go to BOMA, and you can see that it has different modifiers, right? So is bordered, is striped. So how do we giving the developer the ability to add these modifiers? So that's an easy job. We go to here, and actually we're gonna have another parameter, and let's call it, it's gonna be string type, and let's call it CSS plus, right? And we are going to come over here, and I'm going to modify this to dynamically create the classes here. So so CSS class, actually let's use this, it's going to be table, right? So that's the basic thing, and then we are going to have this dot. Okay. It's going to be like this, and CSS plus. If we don't provide anything, I hope it still works. All right, so we're not providing anything, it still works. So let's make it striped. Let's go over here, and then we add another, let's call it CS class, and we add the is striped over here and see whether that works. Refresh the screen again. All right, so it adds the modifiers to it. Right, what else we can add? We can add is bordered, right? Is narrow, is hoverable. This is interesting. Let's add this, and we're gonna add this over here, and go back and refresh. Cool. See, I'm hovering my mouse over the rows, and it's highlighting it. We have learned one of the purpose of having the generic typed list of items, right? We can use reflection to create a grade automatically, and I think you can. I would see myself use this kind of grade pretty often in those cases that I don't care about providing some specific control over the look and feel of each column. And if you care about that, then in my next video, we're going to create another grade that is not automatic and allows the developer to provide a template for each column. If you just need to simply display the list of information in a grade like this, so you can basically have this automatic generated grade component and use it in a lot of different places. You can even provide another parameter for the developer to use to provide the list of names of the columns, because sometimes you don't want to use the variable name. So that's it for today. That we learned one of the ways to use the generic typed list items by creating a automatic generated grade. The most common usage of this is to use this templated component as a repeater. And there's actually another way to use it. I'm going to cover both ways, and let's start with the repeater concept. So let's imagine you have a list of customers. You want to render this list of customers repeatedly following a custom template. And if we try to write a kind of element out, it may look like this. So you want to feed the customers to the repeater component like this. Customers. And then within this, you want to repeatedly render each customer, and you want to provide a template for each customer, and that template can look in your own way. So let's say you want the customer's company name first, and then with the indentation, you want the customer contact name. And after that, you want to see the customer's phone number. And obviously, this is a template. And this template is going to be repeatedly rendered as many times as the number of the customers in the list. So Blazor templated component provide us a convenient way to do this. And let's jump into Visual Studio and look at how we would render how we would create this kind of component in Blazor. So I have so this project I just created, it's a WebAssembly project. It'd be very similar to create the same thing in Blazor server side, but this time let's try WebAssembly. Let's create a new folder. Let's call it controls as usual. I like to call components controls, the non-page component controls. And let's create a component and just call it repeater. First, it's a generic typed temporary components. It needs to have a parameter that holds the data. Right, so let's create a parameter first to host the data. And that data is of a generic type. And it's a list, right? So it is a generic type. And let's call this T item. And that we call it items. And this, you see, it's giving an error because we need to actually say typo parameter is T item. And this will make the error go away. It's a generic type, meaning that you can pass in whatever type you want. So generic in C# is actually a convenient way to use type as a parameter. So we want to render the items one by one. So we need to do a loop. Okay? And so we say item in the items. And here we want to render the template that the user provided. So we need to provide a template parameter. So create a parameter again. And then here is a render fragment. But it's not this render fragment without the type. So it has to be this one with the generic type, and it's with the generic type T item that we used just now. And then here we give it a name. So let's call this the row, right? Because we are rendering the one by one as we're running rows of something. So here we can say, add row, but we can't just do this. It's not gonna render the item. We have to use it sort of like a function, and we provide the item here. We feed the item here. We're telling the row template that this is the item that we're dealing with right now. And then when we use it, let's say I want to use it here. We are going to import the namespace first. Controls. So once we have it, we go into the index component, and let's delete this. Add some line breaks, and then here we're gonna use the repeater component, and notice that it has an items parameter here, but we are going to create some data here. So I have prepared something. So we have the customer here, and then let's initialize it from the onInitialize. Let's override the onInitialize method, and then so now we have a list of customers, and we populated the values of the customers, and we can provide the items here. So then we need to provide the row template. So when we go over here, we can say row, and like we just did in here, we wanted to use customer company name, customer contact name, customer phone number, and the way to do it is to say, hey, we are in the context of the current customer, right? So we give it a context name, and then here we are going to implement exactly the same thing as we planned. We want to have the company name and then some indentations, and with the contact name and phone number like this. But we want an indentation, and we are using the default template comes with bootstrapped CSS, So we can add the left margin. So it's margin left is, let's add 5, make a little bit bigger so that it's noticeable. And yeah, so we have phone number, contact name, phone number, company, and that's, I believe that's what we planned. And let's build this project. The WebAssembly, you have to build it. I don't see a way to just refresh, as in server-side Blazor. So let's refresh, and then let's go here, and you see the the customers are rendered like we planned. And let's give it a little bit clearer formatting. So let's have a line break between each customer, and let's highlight the name of the company so that we can see a better format. And you see, if I just refresh, it would not pick up the changes. And if I build it, it will. So this is the difference, one of the differences between Blazor side, server side Blazor and client side Blazor. So now I pick up all of the changes that I have. This is the first way, and it's the main way to use a generic typed templated component. And usually a repeater also comes with a header and a footer, right? And I would implement that as well, so that we would have a render fragment without the generic type, and I would call it header, right? And I would have another one here, we call it footer. And if you want to put something as a header or footer, you can use it. And in our case, let's use the header today. And in the header, I just want to, let's say we just give it a title. It's H2, and let's say this is customers. And render this right over here. You see, because we are giving the user the control of the template, so we don't want to add a div, anything around this header or in between, because that will interfere with the user's control. So now I have the customer right here and have all of this. And if we want, we can add some margin over here as well. But in this case, I'm going to skip that. So the second way, using the generic type parameter, is actually pretty interesting. That if you look at the documentation from Microsoft, right here, it only talks about the way how to use it as a repeater, right? You basically repeatedly render the item in the item list. But there is a way to render a form by using the generic type parameter. Today I'm going to show how to use that to create a kind of an added form template to edit each one of these customer. And to do that, let's create another parameter. And that parameter is a T item. You see, this becomes interesting because the documentation doesn't mention anything. If you use the T item, it has to be a list, right? But we are going to come to this interesting part of it by declaring a parameter without a list. So we have a T item here, and then we're going to say item to edit. So this is the item for editing only, and then we're going to provide another render fragment that we can use this item to edit. That is going to be a render fragment with a generic type, and yes, it is the same generic type. Let's call this edit template, and you can, usually we display an edit form in a dialog, like a model dialog, but in this case, I'm just going to display right under the footer, because we have a footer. I forgot to render the footer. So let's display it right under. We'll have a line break. So display this form right under here. So we're gonna say added template, right? But then again, because this is a generic type, you have to use it as a method. And so what are we gonna provide here? So we have to declare. We already declared this. So I'm gonna provide this as a parameter here. So basically, we're telling Blazor that we are rendering this. Edit template. Sorry, this render fragment right over here, and the data we're gonna use is the item to edit, right? And then when we use it, basically we have to provide this item to edit with the item that we want to edit. In our case, it's the customer that we want to edit. So to do that, we want to change our template to provide an edit button, and that will go under the first div. And we're gonna write a space here, and then we're gonna write a button. And since we're using let's just call it a button. We're using Bootstrap, so we're using Bootstrap class, and then we call it edit, right? And the event handler of editing, we are going to say edit. We're going to say edit with a parameter, right? And that we're going to say edit. Edit what? Edit the customer, right? Because we have the context here, so we are editing this current customer, right? Let's just call it edit customer, and then we're gonna create this method right here. So it's gonna be private void, and then we're editing what? We're editing a customer. So this is the customer. Over here we have to pass this customer to the repeaters item to edit. So in order to do that, we have to reference our component. So we create a reference right here. It's a reference, and we just call it repeater. Simple and clear. And declare that right over here as well. Repeater. And this is our customer. We're dealing with customer, right? So provide this and repeater, and we call the repeater right over here. We say when we edit, we want the item to edit to be the current customer we are trying to edit. And then I believe we're gonna see an error here. Yes. Why? Because it says component parameter should not be set outside its component, right? So what we have to do is we have to remove this attribute, right? So we are having this over here, and we are having this over here. We don't want to display the template unless we're trying to edit, right? We're in the edit mode, so we have to have a logic here. We're gonna say this dot item to edit only when it's not. Now do we display this edit template? We can implement the edit template like this, and we are going to display, and we're gonna have we're gonna say component name. We'll make it simple, and we just use input with a class. So it's Bootstrap is form control, right? And we're going to bind it to we're gonna specify a context right here. So the context is the current customer, and then I'm gonna call it the current. We'll call the current customer, and then specify the property to bind to, and and come over here and make sure this is assigned correctly, and then we build it, and let's refresh. All right, so let's click on first customer. Yep, this time we see the company name. So in one of the future videos, I'm going to talk about Lifecycle, and here we are seeing that we're actually triggering the event from the parent component, and usually, and also we notice that this item to edit was defined not as a parameter. So usually changing the public property that is not a parameter outside of the component will not actually trigger a re-render, but in this case it did. And the reason being is that one of the ways to trigger a re-render of a component is a event, right? Handling event. Although this event is handled outside of that component, right, the repeater component, but because you see this event is triggered right here, right over here on click event, and this button, although it's defined outside of the repeater component, but because it's provided as a template, so that is actually rendered by the repeater component, and so any event handling for this button is also considered as a like its own event handling, as the repeater component's own event handling. Therefore, when you trigger this event, it automatically render the repeater component. So we're going to talk more about that, about the lifecycle in future videos. So yeah, so let's take a look at this. And we have a form, and if we have a dialog, then we can display this in a dialog, and any changes is actually applied right there, right? So you can change the name, you can change a phone number right there, and and it actually works. And then you can click on different things, so the company and everything changes. And if you come back, you see the changes actually retained. So yeah, this is a very interesting way to use the template component. If you're more creative, then you can actually take advantage of this very well. So the second way, using the generic type parameter, is actually pretty interesting. That if you look at the documentation from Microsoft, right here, it only talks about the way how to use it as a repeater, right? You basically repeatedly render the item in the item list. But there is a way to render a form by using the generic type parameter. Today I'm going to show how to use that to create a kind of an added form template to edit each one of these customer. And to do that, let's create another parameter. And that parameter is a T item. You see, this becomes interesting because the documentation doesn't mention anything. If you use the T item, it has to be a list, right? But we are going to come to this interesting part of it by declaring a parameter without a list. So we have a T item here, and then we're going to say item to edit. So this is the item for editing only, and then we're going to provide another render fragment that we can use this item to edit. That is going to be a render fragment with a generic type, and yes, it is the same generic type. Let's call this edit template, and you can usually we display an edit form in a dialog, like a model dialog. But in this case, I'm just going to display right under the footer, because we have a footer. I forgot to render the footer. So let's display it right under. We'll have a line break. So display this form right under here. So we're gonna say edit template, right? But then again, because this is a generic type, you have to use it as a method. And so what are we gonna provide here? So we have to declare. We already declared this. So I'm gonna provide this as a parameter here. So basically, we're telling Blazor that we are rendering this. Edit template, this render fragment right over here, and the data we're gonna use is the item to edit, right? And then when we use it, basically we have to provide this item to edit with the item that we want to edit. In our case, it's the customer that we want to edit. So to do that, we want to change our template to provide an edit button. And that will go under the first div. And we're gonna write a space here. And then we're gonna write a button. And since we'll just call it a button. We're using Bootstrap, so we're using Bootstrap class, and then we call it edit, right? And the event handler of editing, we are going to say edit. We're going to say edit with a parameter, right? And that we're going to say edit. Edit what? Edit the customer, right? Because we have the context here, so we are editing this current customer, right? Let's just call it edit customer, and then we're gonna create this method right here. So it's gonna be private void, and then we're editing what? We're editing a customer. So this is the customer. Over here we have to pass this customer to the repeater's item to edit. So in order to do that, we have to reference our component. So we create a reference right here. It's a reference, and we just call it repeater. Simple and clear. And declare that right over here as well. Repeater. And this is our customer. We're dealing with customer, right? So provide this and repeater, and we call the repeater right over here. We say when we edit, we want the item to edit to be the current customer we are trying to edit. And then I believe we're gonna see an error here. Yes. Why? Because it says component parameter should not be set outside its component, right? So what we have to do is we have to remove this attribute, right? So we are having this over here, and we are having this over here. We don't want to display the template unless we're trying to edit, right? We're in the edit mode, so we have to have a logic here. We're gonna say this dot item to edit. Only when it's not now do we display this edit template. We can implement the edit template like this, and we are going to display, and we're gonna have we're gonna say component name. We'll make it simple, and we just use input with a class. So it's Bootstrap. That is form control, right? And we are going to bind it to we're gonna specify a context right here. So the context is the current customer, and then I'm gonna call it the current. Call the current customer, and then specify the property to bind to, and that. And come over here and make sure this is assigned correctly, and then we build it, and let's refresh. All right, so let's click on first customer. Yep, this time we see the company name. So in one of the future videos, I'm going to talk about Lifecycle, and here we are seeing that we're actually triggering the event from the parent component, and usually, and also we notice that this item to edit was defined not as a parameter. So usually changing the public property that is not a parameter outside of the component will not actually trigger a re-render. But in this case, it did, and the reason being is that one of the ways to trigger a re-render of a component is a event, right? Handling event. Although this event is handled outside of that component, right, the repeater component, but because you see this event is triggered right here, right over here on click event, and this button, although it's defined outside of the repeater component, but because it's provided as a template, so that is actually rendered by the repeater component, and so any event handling for this button is also considered as a like its own event handling, as the repeater component's own event handling. Therefore, when you trigger this event, it automatically render the repeater component. So we're going to talk more about that, about the lifecycle in future videos. So yeah, so let's take a look at this. And we have a form, and if we have a dialog, then we can display this in a dialog, and any changes is actually applied right there, right? So you can change the name, you can change a phone number right there, and you know, and it actually works. And then you can click on different things, so the company and everything changes. And if you come back, you see the changes actually retained. So yeah, this is a very interesting way to use the template component. If you're more creative, then you can actually take advantage of this very well. Blazor components are stateful component, and if we don't have a good understanding of the component's lifecycle, as developers, our mind can be confused, and we don't know where to put the logic that we want to implement. Today, I want to cover one of the core concepts of component lifecycle, which is when do a components render? Components actually render under 4 conditions. Components render when components are just created, or when components events are triggered, or when components parameter values are changed, or when developers manually trigger the rendering of the components. So let's cover them one by one. First one is when components are just created. Right, so let's take a look at Visual Studio. So this is the project that I just created with Blazor WebAssembly, and let's see. The first one is the components renders when it's just created. Right, so this one is easy, right? The reason it's obvious that when a component is created, you want to render the component. Otherwise, like it's a UI component, right? So it needs to be displayed. So, but when is component actually created, right? So the component is created when you just load the component for the first time, or when you navigate away and navigate back, right? Or you try to refresh the page and the components are recreated. So let's see whether that's those three things that I said it's true or not. So let's take a look at the counter component. Okay. Let's see if we override on after render method, and if we run this, so we pressed Alt Shift D, and so this is the page as we see, right? And we're using Chrome, so we just copy this, right? Control C, and then we use Windows R. See, it's writing right here. So Windows R, and we paste that in, and then click on OK. So we'll open another browser. So this is actually the browser that we need to use in order to debug. So from here, we do Control Shift D again, and this is the window that is launched. So from here, we can actually set breakpoint. So go to the Files folder, and then we can see all of even the program files, right? So we can go to our counter component and see whether this is rendered. But debugging this is pretty tricky. So if we just refresh this counter page, we can see that the breakpoint is not actually triggered. So yeah, it doesn't actually trigger the breakpoint for the first time when the component is just created. So in order to debug, go to our code, and then we can just write console.writeLine, and this is very similar to console.log in JavaScript. And then we save it and we build it. So once we build it, we come back to this developer tool, and we go over here, refresh it, and come back to the developer tool. If we look at the file is actually changed, as you can see. Let's refresh again, and then we go to the console, and you can see that on counter component on developer render is rendered at this time. So now we know that when the component is just created, the component is rendered, right? Because this event is only triggered after it renders. So this kind of proves that the event is just rendered. Another possibility is that if we navigate away, right, and we navigate back, then see the breakpoint is also triggered, and its first render is true, meaning that it's just rendered. It's just created, therefore it's rendered, right? So those three conditions. First one is when you just come to the page. Second one is when you refresh the page. Third one is when you navigate away from the component or from the page and come back to that page that contains that component. Then the component is created, therefore it's rendered. The second one is the component renders when the component's events are triggered. So for example, in this counter component, some people think that this current count, only when the current count changes, does the component re-render, but that's not actually true. So let's actually comment out this line and then rebuild the application. And once that's done, let's go back to here and let's refresh the page, right? Once we refresh the page, we can actually go to the source code and we can see that the counter component actually doesn't have that. See, this is the counter component, so this is already commented out, right? So this line will not actually run at all. So what we can do here is that we click on it. See, these after render event is also triggered. So this proves that as long as there is an event that is triggered, then the component is re-rendered, right? And you can see that this parameter is false, meaning that this is not the first time. This is not the components just created. This component already created, and we clicked on a button, and that button does nothing, but the component is still re-rendered. So that's the first point I want to emphasize here. The second point is that when events are triggered, that's true, but it's not every single type of event. It has to be a UI event, like clicking a button, change a drop-down list, that sort of thing. It has to be a UI event. So let's do a demonstration that what if we are increasing the counter count by a timer, right? So if we come to the application and if we add a timer here, so basically we create a timer that runs every 2 seconds, right? 2000 milliseconds. And then it triggers the increment count function to increment the current count value. And let's run it and see what happens. So let's refresh the page. So it picks up that, and you can see that the current count is not actually increasing. But if we go to the page here, we go to the console, we can see that the counter value is actually being increased every 2 seconds, right? But this event is not a UI event, therefore it's not rendering re-rendering the component, even though the variable's value is actually being changed. And if we click on it, you can see it's 18. Why it's 18? Because it's 18 right here, right? It's 18 right here. That's when it rendered, because we clicked on that, and that's a UI event. That's why it has this. So that's that one. As long as it's not a UI event, it cannot. For example, if you have an event in a child component or in a parent component, and you're implementing a method that registered to that event, and when the event is fired from the parent or the child components, and you have a function within this component to be called, and even when there's variables that are being changed, and that even when that variable is actually being used on the UI, your component will not be re-rendered just because it's not a UI event, right? So similar to the timer event. So another point that I want to emphasize, when the component UI events are triggered, the component is re-rendered. That's usually the case, but that UI event has to happen within the component, right? It cannot happen outside the component. If it happens outside the component, it's not going to be rendered. So for example, if you have a parent component, the parent component has a button, and if you click on that button in the parent component, the child component will not be re-rendered, right? And if you have a child component that has a button, you click on that button, the parent component cannot be rendered, will not be rendered. We can do a demonstration, but let's stop this timer. So I want to create a component right here. Okay, you can see the component is rendered, and if you go to our developer tool, you can see that the counter component rendered and the child component also rendered. The child component rendered after the counter component render, after the parent component render. But if we come over here and click on the click me button, and we go over here, you can see the counter component is rendered again, right? But it's not actually triggering a re-rendering of the child component. The child component is not being rendered. So if I'm going to click on this a few more times, right, you can see it's all about the counter component. The child component is not rendered, right? And the same thing will happen again if you put a button under the child component, and you're gonna see that the child component renders. Let's actually do that. Let's go to the child component, and let's put a button right here, and let's have a method. Right, and we refresh, and we come to the window, clean it up, click on Click Me. We'll see the child component actually rendered. I also click on it a few times, three more times, you can see. Right. So the important thing to notice here is that although the event handler here is not doing anything, you have to have an event handler in order for the component to re-render. Right, although it doesn't do anything. And also another thing, you notice that the rendering is only the child component renders. The parent component actually does not render, right? So, and but there's only one exception. So this is the point that I want to emphasize, that the event has to trigger from inside the component. Only when the event that is triggered inside the component does that same component gets re-rendered. So, but there's only one exception when you use a templated component, right? So let's say that we have a template. So I have covered the templated components in a couple of videos, couple of episodes ago. So if you are not familiar with template components, please go back and look at my previous videos. And refresh. We see this click body template, and let's clear the console, and we click on the body template. I click on it once, and we see that the counter component gets rendered, and the child component also gets rendered. Right? So if I click on 2 more times, 1, 2, go here, you can see that both counter component and child component get rendered. So why is that? Well, the reason is that the body template is kind of special, that when you have buttons or HTML elements within the body template or a template within a template, it's also considered part of the child component, right? It's considered, so this button is considered part of this component. So when you click on the button, it's as if you're clicking a button within that child component, right? It's actually part of that. It's actually within it. But because the fact that it is also part of it's also defined right in the parent component, so that's why the parent component is also rendered. Okay, so that's the second bigger topic here. The components re-rendered when the component's events are triggered. So I covered the 3 important things I want to emphasize again. So events, we don't need variables to be changed as long as you have an event handler for event. Even the event handler, you do nothing about it, the components also gets re-rendered, right? So second important point is that the UI, the event has to be a UI event. Any other events like a timer, timed event, or a event delegate, you register to an event delegate within some other components, and that event gets triggered within this component will not be re-rendered when the event happens. The third thing that I wanted to emphasize is that the event has to be triggered from inside the component, not outside the component, except for one case, that if you have templated components, then that template, the event happens within that template triggers both the parent and the child component. So okay, so now let's move on to the third thing, which is the component parameter values changed. Well, this is a simple one. If we go over here and we go to component, and if we create another parameter, and that parameter would be the counter. If we just display the counter value right here, so where's the counter? Okay. And from the parent component, if we feed that counter value right here with the current count, then every time you click on the button, every time you click on this button, the click me button, your child component also gets re-rendered. Right. So let's delete everything that is distracting. And we don't need this either. We don't need the template component. We don't have this, and we don't need this. We build it. So here, if I click on it, you can see that the counter value does not change. So because we are not passing it, and if I click on it again, you can see that the only thing that it changes, it gets re-rendered, is the count component, which is the parent component. But if we go to here, go to the parent component, and if we pass that parameter right over here to be the current count, and if we build this and we refresh the page, and while we click on it, we can see that all of them, so both the parent component and the child components get re-rendered every time we click on it, right? So you can see both are re-rendered. So that's the third. And the fourth condition is when developers manually trigger the rendering. So again, if we remove this, and if we just come over here and even we remove this, and if from here, if we reference the child component, let's say child, and then over here we can say private component child. Right, so this is that component, and if we just every time we do this, we say child.counter equals current count. If we do this, let's see what happens. So basically, we are increasing the counter value of this property. Right, it's not a parameter. But we're not expecting that this value would change. So you can see that it's not changing, right? Although the value gets increased. The only reason why it's not changing is because the child component is not rendering. That's because none of our four conditions are met, right? We're not doing any of these, so the child components is not being re-rendered. So in order to re-render, we have to, as developer, we can manually trigger that re-render. We can have a public method called re-render. This state refresh, and we call it, and then when we come over here, we can call child.refresh, and that will trigger the re-rendering of the child component. And let's go over here. Refresh the page to pick up the change, and let's do this. You can see that both the counter component and the component and the child component pick up the change. And if we go over here, we can see that we can see both are re-rendering. Okay, so that's everything I want to cover today. Remember, there are only 4 conditions that the components get re-rendered. First is when components are created. Second one is when components events are triggered. Third one is when components parameter values are changed. Third one is when developers manually trigger the re-rendering. So I'm going to cover the sequence of each one of the lifecycle event in terms of in what sequence they are being triggered. So I'm going to cover both the server-side Blazor as well as the WebAssembly Blazor. I'm going to divide this into 2 categories. The first one is the first time rendering, right? And the second one is after the first time. So the first time rendering is when the page is just loaded, or when you navigate to the component, to this page component. Let's first cover the first category with server-side Blazor. So I have server-side Blazor default template. I have all of the events written down and have breakpoints. Same with the child component. I have all of the events and I have the breakpoints for each one of them, and I have the child component used by the parent component. So I'm going to run debug, and let's pay attention to in which sequence these events are triggered. Again, this is server-side Blazor. Right, so the set parameters async in the parent component is triggered first. And then I'm going to hit continue, and initialized second, parameter third. And when I press continue again, now I'm expected to go to the child component instead of carrying on. So I hit F5, and the set parameters async in the child components are hit. And secondly, the initialize is triggered in the child component, followed by parameter set. So if I press continue again, it's actually not going to go to the should render or after render. Same with in the parent component, these 2 events are not triggered. So let's go over here. This is where our breakpoint is currently at. So I'm going to hit continue again. Now we're jumping back to the parent component, and again the set parameters async is rendered and initialize, and then so initialize and then press continue again on parameter set, and then actually when I click on continue, it's going to jump over here again, and then initialize and then parameter set. So why are they rendered twice? These 3 events are rendered twice. That's because if you look at the diagram, we have the browser and we have the server side. The first request sent by the user, and then the first rendering is, so this is again, this is server side Blazor. Okay, server side Blazor. The browser sends a request first, and then it renders for the first time, including the JavaScript for server-side Blazor. And that JavaScript establish a signal R connection, and then server-side renders the component again. That's why it rendered twice. That's why those 3 events are called twice. Right? So after this, what happens if I continue from here? So I jump back to the parent component and calls the on after render, skipping the should render because this is the first time and it has to render. It doesn't make any sense to allow the developer to control whether to render the component or not. It has to render the component. And then I continue, jumping to the child component, calling the on after render event handler again. If I continue, now the page is rendered. I want to emphasize that the double rendering only happens when the component is loaded for the very first time. So if you navigate away from the component and then navigate back, because the signal R channel is already established, so those three events that are called twice will not be called twice again. So let's demonstrate that. So let me refresh the page. Okay. So we notice that we're on the parent component, three events. Child component, these three events. Going back to the first parent page, these three events. And secondly, on the child component, so we noticed so far, these three events are called twice on both the parent component and the child component. That's because I refreshed the page. By refreshing the page, the signal arc connection is reestablished. That's why these three events are being called twice. And then we're going to the on-after render on parent page, parent component, and on-after render on child component. Right. So if I'm not doing that, if I navigate away from the home component, from the index component, and navigate back to the index component, watch what happens now. Okay, these three events, and then child component, these three events happen again. But then those three events are not going to be called twice. So we're actually moving on to on-after render for the parent component, and then on-after render for the child component. Okay, let's summarize. So the event sequence that we are experiencing in server-side Blazor in the first category, which is the first time rendering, is that these three events are being called one by one in the parent component. And then the same set of events are being called in the same sequence in the child component. And then after that, the same thing happens again, right? For the parent and for the child, and only after that, the parent component after render is called, and child component after render is called. Seeing this, any initialization code that you put inside these three methods on server-side Blazor is going to be called twice. So when you're initializing your data, you have to really pay attention to where you put your initialization. There is a on-after render async with a parameter that indicates whether it's the first time or not. So for server-side Blazor, I recommend that you use that to initialize your data in the on-after render. Depends on whether you are going to use that data to render on the screen or not. If yes, then you need to call state as changed method to re-render the page again. Now let's look at the same thing in Blazor WebAssembly, because it does not actually trigger the breakpoint. So you can either debug it through the browser, which I have demonstrated in the previous episodes. So today I'm going to actually use console.write. That is similar to the console.log in JavaScript. So you can just do this and then expect to see the log is written in the console window in the developer tool. So I'm just going to do that. All right, let's go to Blazor. Let's go to developer tool, and we can see that it's actually the same sequence, right? Parent component called this three events. Child components again, it's the three events, and then parent components called on-after render. Child component calls on-after render. The only difference is that the parent component, these three methods are only called once. Because this is WebAssembly, thus the second rendering is no longer needed because there's no signal R channel that is established. Now let's moving on to the second category, which means re-rendering, right? And from the previous episode that we know there are 4 different cases that would trigger a re-render of the. Let's use a button. I have a button here. And I have an event handler here. So this is server-side Blazor. So I have a breakpoint set up right here. And let's run it and see what happens. If I click on the click me button, the first event that is called is actually the event handler of this button, right? And then after that, so we are on the parent page. The button is only on the parent page, parent component. So I click on the continue button. We're calling the shoot render. And then if I click on it again, we're calling on the on after render. And notice that we're still on the parent component. And you see that the child component re-rendering is not called. If you watched my previous episode, that you know the reason why the child component is not re-rendered, right? So none of those 4 conditions satisfy, so the child component are not going to be re-rendered. Alright, for the second category, which is the re-render category, let's summarize that it actually looks like this, right? So first you have your parent component. And if there's no condition for the child component to render, what you're going to see is something like this, right? You have your parent component shoot render, and then your parent component after render. And if there's parameter change or any other condition that triggered re-render of the child component, what you're going to see is something like this. You're going to have your parent component shoot render, and then these 3 events, and then parent component after render, and then child component after render. Something that is interesting I want to point out is the shoot render. Okay, so let's do a let's change this to return false. Okay. Now let's see what happens. So I'm going to click on the click me button, and then the event handler of the button is called first. Go into shoot render. And then you see that the count is not changed, and so that means the child component is not re-rendered, and the parent component is actually not re-rendered. We did not go, we did not move over here. We didn't see the breakpoint of this on after render is called, so it wasn't rendered. So for the second category, which is a re-render scenario, the server side and the client side Blazor, like the WebAssembly Blazor, are exactly the same, so I'm not actually going to run the demo again. I want to go over a pitfall in data initialization in Blazor components. So I have a parent component, which is the index component, and an employee detail component right here, right? The parent component is using the employee detail component to display the details of the employee, and the employee is initialized or loaded in the parent component. And I'm hard-coding the employee here to mimic the situation that we're loading this employee, and each employee actually has a bunch of records to be loaded. Once we go into the employee detail component, this employee is the records of the employee is loaded. So if we look at this code, we have all initialized here in the child component, and also all initialized here in the parent component. And if we run this, there's going to be no problem, right? So let's demonstrate that. As you can see, the home page is loaded with the employee detail. There's no problem. Nothing is wrong with this, but it actually has a potential issue. What if this employee is loaded slowly? There's some kind of network slowness, or a lot of data needs to be loaded. So let's use the sleep method to mimic that scenario. So let's go back and refresh the page. Okay, still no problem. When we navigate away and navigate back, it takes 5 seconds, right? 4, 5, right? So 5 seconds to load it, but there's no problem, right? But the potential problem is that sometimes you have to load these in asynchronous version of the initialization, or in some other lifecycle events, right? So instead of using the synchronous version, you may have to use the asynchronous version. So let's demonstrate that. So instead of using this, if I use this kind of code here, right? And then if we use this asynchronous version here as well, then let's refresh the page. All right, there's no problem if we navigate back. Still no problem, right? That's because this is actually called first, right? And then the initialize methods in the child component called secondly afterwards. So what if we add that sleep thread back, right? So what if we have a method like this in our parent component? We're using await task.run to mimic a asynchronous call, and then we use the sleep for 5 seconds to mimic a long running process here. And let's refresh the page and see what happens in this case. Right, so it throws an exception complaining about the object reference is null, which happens in this place. The employee is null when the low records is being called. So that throws the exception. How should we deal with this kind of situation? Right, I would suggest that we first we need to call. We always check whether the object that we're trying to deal with is null or not null. We need to do the null reference check. And then also, instead of using uninitialize, I suggest that we use onParameter set because it's always called when parameter is changed. And then inside here, we have to check the reference as well because we don't want to load the records over and over again, right, whenever there's a change. Unless that's something that you intend to do. So in this case, we will see that if we refresh the page, then it's going to be fine, except that it takes 5 seconds. 1, 2, 3, 4, 5. Right? Navigate away, navigate back. 2, 3, 4, 5. Traditionally, we're using the regular forms for user to input data. And if we look at the contents of this, we have a form element, and then we have input field, and then a submit button. So when user clicks on the submit button, the forms will be posted back to the backend, to this location. But application written with Blazor is a single page application, which means only the first page load goes through the HTTP request and response pipeline. The subsequent actions will not be posted back to the backend. In order to still perform form submissions, Microsoft came up with a set of components to perform the task. So instead of using regular forms, in Blazor, we should use the edit form component. And instead of using the regular input, we should use input text, input number, input date, input select, etc. Don't worry about the error here. I'll fix this error later. When the submit button is clicked, event handler specified, which is valid form submitted. And if you want to handle invalid form submitted, so then you would do invalid form submitted and connect it to a function. Right, so here's two things we need to know. First, we need to use an added form instead of a regular form, and then we use input fields differently. Another thing we need to know is in order to handle the submission, right, we specify a method. The next thing we need to know is that the edit form has to be bound to a model. I declared a model class here, person, and then I initialize the person right here. And then in edit form, there is a parameter that is called model, and I provide that person model instance to this model. And next, I need to use bind value to do data binding, and I'm associating each properties inside the person class to the input elements. And the next thing we need to know is validations. In order to validate the model, we can use data annotations. We need to first use that namespace, and then we can annotate the properties which the annotation attributes, like required, string length, max length, range. We can specify the data type, like email address, etc. In order to trigger the validation and display the validation messages at the top, we need to use the data annotation validator component, and also we need to put validation summary here. And that's all we need to do for a basic validation scenario. Okay, so let's run this form and see what happens. All right, so if I don't do anything, I click on submit button, it will give me the required error messages. If I put -1 here and click on this, it would give me the range error message, and emails is also still required. If I put abc.abc, so let's put this, then it will directly say that email address is invalid. Okay, so if I provide a correct email address format, then this becomes green. And if I give it a correct number, then everything is green. Okay, and the submission will trigger the onValid submit event, and this event handler will be triggered. Okay, so that's the basic of validation. I just wanted to, before I finish this episode, I wanted to mention a couple of things. Notice that this V is a capital V. So usually when you use a data binding outside of added form, you would use a lowercase v. And if you keep using the lowercase v, you will encounter very weird errors. So remember to use capital V here. Another thing is that if you put buttons here, like this, the button's default type is going to be a submit button. Right? So if you put buttons here expecting it behaving like a regular button, it's not going to happen. It's going to work like a submit button. Right? So if you want actual buttons to work just like a button, then you have to specify it as a button. First, I will quickly go over what dependency injection is. So we will have two modules or two classes. One is higher, the other is lower, and the higher one depends on the lower class. For example, the customer service class needs to use the functionality of the customer data access class, right? In order to get data from database. Then we say that customer service is a dependency upon customer and data access class. In order for the higher module to use the functionality of the lower module, we have different ways to do it, right? The first obvious way is to have an instance of this customer class right over here, right? And then we just call it customer DA, right? And then in our constructor, say custom DA equals new customer data access, with probably with a connection string from somewhere, right? And then you can use it to, for example, get customers, right? And then in here, we can just say customer return customer dot get customers, and that's actually you'll have a enumerable, right? So we get a list of customers like this. So this is one way to make the to make use of the functionality of the lower module. But as you can see that the customer service is tightly coupled with customer data access. It is aware of the definition of this class, and there are many different problems with this. For example, if you want to have different teams work on higher level object, one team work on higher level module, the other team work on lower level module, because this tight coupling, it's very difficult to work in parallel, right? And also, if we were to change this, the name of this class, then you have to go to change all of the codes over here, right? You're gonna change this, you're gonna change this. So and you need to recompile the higher modules in order to do that change, right? So the maintainability is not good, right? And later, if we want to, so if this data access layer is going against a file system, right? And later you want to create another class, right? That's going against a database, right? SQL database, for example, like this, right? Then you would have to go inside and change the code, right? So that's extendability is also not good. So there's many different disadvantage of doing this kind of tight coupling. So there's this dependency inversion principle, which says higher level modules should not be dependent on lower level modules. Both should be dependent on abstraction. So what is the abstraction? Abstraction is because there is the dependency between the service class and the data access class, right? So that dependency cannot be removed. Instead, what we need to do is to abstract that dependency, and that dependency is the functionality, right? So dependency is the functionality, and we need to abstract that functionality. And in C#, the way to access abstract that functionality is to use interface. So we can create an interface like this, right? And then we can say customer data access, and in there we can just say, all we want to do is to have get a list of customers. This is the abstraction, right? So basically it just says I have a way to get customers. Then whoever implements this interface will have to implement. Notice that this method doesn't have a body, right? It doesn't have an implementation. So whoever actually implements this interface, right? They need to have this thing implemented. So over here, we need to implement this in the concrete class. Right? I'm not going to implement anything. I'm just going to do this. Right? So in this way, we are not actually using the concrete class here. We're just doing this, and that takes the dependency away. But again, it's still having the same problem. We're actually creating this instance of this concrete class. Right here means that the higher level object is still aware of the lower level object. So how do we do that? We have to take this responsibility away from the customer service, and this responsibility is the instantiation responsibility, and we need to take that away, and this is called an inversion of control, right? But don't worry about that. And how do we do that? We need to create it from outside, right? The simplest way is just to create it from outside, like this. The A, let's use a different variable name, right? And you can just do it this way. And then when this class is instantiated, we can just do it like this. Okay. And then we can say DA equals DA, and that's it, right? So our private instance has this, and then from outside when we instantiate this class, then we can just say, pass this into it, So these are the main two steps. First, we need to use an abstraction, which is interface in C#. Right? Secondly, instead of directly instantiating the concrete implementation of the interface, we use constructor and then pass that instance from outside into here. So this is the dependency injection in C# and it's the same concept in every other languages. Of course, there are different ways to do it. This is through the instructor. You can also create a property of that, and then just say, if we were to create a property, instead of doing it like this, we can just say have our constructor stay right here, and then we can just say public so in that case we don't need this, right? We can say customer data access, and then we can say customer data access equals well, let's use this name because it is equals get and set. So this is the property in C#, and then when you use it like this, you can just say instead of doing it like this, you can just remove this, and then from here service, and then you can say custom data access equals data access, and then you can use it in other methods. So that's dependency injection in general. And then next, let's go into Visual Studio and see how dependency really works in Blazor components. Let's see how dependency is injected into Blazor components. First, let's look at server-side Blazor. Let's create a class. Let's call it customer service. This customer service will have a public method that returns a customer. And for that, let's first create a customer class as well. And that's it. Let's keep it simple. And in here, we'll return the customer. We'll say get customer by ID. And the parameter is an integer, which is the ID. Right? We'll create a constructor. And in this constructor, let's initialize a list of customers. And then in here, okay, so we have this service, and we want to inject it into Blazor components. And let's inject into the index component, which is a page component that has a routing path here. Right? So let's delete this survey prompt. And let's use this in our code. Right? So one way to do it is to declare a customer service, and then we'll just say customer service equals new customer service. Okay. So this has this dependency problem that is making the index component tightly coupled with the customer service class. But that's not what we want to do. Right? So we have learned what dependency injection really is. There are two main steps. First is that we need to use interface so that our index component is dependent on the interface. So what we need to do is to create an interface. Okay. So give it an interface. Was it customer service, right? There's only one behavior right here, which is getting the customer by ID, right? So we copy that and paste it over here, and that's it. That's the what's it must declare a body. Oh, okay. Yeah. So this is abstraction, so it doesn't need a body. And then going over here, we just use our customer service. Right, so we have already implemented the abstraction. And the second step is to inject. Right, so first we need to register into the container, which Blazor is based on ASP.NET Core, and ASP.NET Core, there's in order to register the service classes into the container, we can use configure services. Right, so we can register right here, but there are actually 3 different lifetime scopes. Right, there's singleton, there's scoped, and there's also transient. Right, so first let's examine transient, given the pair of the interface as well as the implementation. Right, and then when we ask for it, we go to our component where we want to use the customer service, and we just say inject, right? Inject customer service, right? And then right over here, we can just declare a private, customer. This is our model class, so it's okay to be dependent on our model class, right? So, and then in the override, let's override right? I just want to set a breakpoint, just so that I can show you when this component is disposed. Right, so I'm going to debug. So if I move away, you can see when I move away, it actually disposes. Right? When we move back, it creates again. When I move away, it disposes, and when we move back, it creates again. And if you pay attention to these numbers, right, 767, when I move away, let's remove the breakpoint and move back, number changed from 767 to 1B7, right? You can see every time I do this, the number changes. And the reason, every time I move away, you can see the dispose method. And navigate away from the index component, you can see the dispose method gets called because the index component corresponds to this home page, right? So this dispose method gets called, which means that every time I move away, this component is actually destroyed. Right? And when I come back, this component is created. Whenever it's created, this dependency injection injects the class to our component. Then we can use it here. Right? So this is, and every time it changes, and this is the behavior of transient. Transient says that I register a service to a container, and every time I ask for an instance, the container will create a new instance of that class and inject that into our component, right, into where we want to use it. So that's what we call transient. And if we want to see what scope means, let's actually see what singleton means first. Right, so let's change this singleton, and this time I'm actually going to use Control F5 to debug it, well, so that I can run it without debugging. Actually, I'm not debugging it. Alright, so you can see that we have this number here, and if I move away and move back, you can see the number does not change. So that's singleton. Singleton means there's only one single instance of the object, the customer survey object, in the container throughout the lifetime of this application. Right? Even when you refresh, right, which actually resets the connection, you can see the number does not change, and that's the behavior of singleton. Singleton, there's only one instance, and if we want to look at how scope means, how scope works, let's change this to scoped. Alright, and then let's come over here, refresh the screen, because we used Control F5, so this hot reload works. So let's refresh it, and you can see the number change, right? And then, but if we navigate away and navigate back, you can see the number still the same. It doesn't change. So it seems like it's a singleton, but it's not. So if I refresh, which by refreshing this, it disconnects the connection and reestablish the signal R connection, right? Because this is Blazor server side. So then the connection is broken and reestablished. So you can see this time the number changed after I refresh. And that tells us that the scoped lifetime configuration makes the service live as long as the connection. Right? So as long as the connection does not get disconnected, you will always have one instance. You have to choose the best suitable lifetime configuration for your services class, right? Because some of them you want to use transit, some of them you want to use scoped for better performance or for whatever reason, and some of them you want to use singleton, right? For example, if you want to use some classes to contain some data and try to implement state management that way, and you don't want to use singleton because that way you are sharing the data across all of the users, right? Even users from different browser sessions from different part of the world are going to see the same data unless that's your purpose. So for state management that is very specific to a particular user, you can use scoped, and that's related to that one particular connection, which cannot be shared between different browsers, right? But for very light services, you want to probably use transient, right? For services that is not thread safe, which means concurrency doesn't work. For example, the DB context from Entity Framework, you don't want to use singleton, you don't want to use scope. Even for transient, it's created every single time, it may still have problems. So you really want to consider the different services and different scenarios. So this is Blazor server side. So next, let's look at Blazor WebAssembly. We're going to have another instance of Visual Studio 2019, and then we click on Blazor app. This time, we don't see that startup file. That's this is WebAssembly, so it doesn't actually have it. And you can see that they are registered right here. So we can do a similar thing. We can say builder dot services dot add transient. So we're gonna say customer service. Okay, so we don't have this namespace is wrong. So we have our customer service, provide this to it. So basically we're just saying that for this interface, this class implements the interface. And then when we ask for an instance of this interface, the container, the built-in container is actually going to create an instance for us by instantiating this customer service, right? And what we want to do here is same thing. We're gonna do it within here, where we will inject our customer service over here, and then we are adding this. We're actually going to copy this code from right over here. Here we register transient, right? So let's run it. Control F5 again. So we have this running, and we can see the number is CE2D when we move away. Number change, move away, number changed again. If we refresh, number change, right? Refresh again, number changed again, right? So this is transient, right? So basically, it's the same thing as Blazor server side, where every type of components class is instantiated, a new instance is instantiated, and injected into the component, right? So that's that one. And then singleton actually basically works the same way, right? Which is also, every time you ask for it, you're gonna have the same instance. Alright, so refreshing, downloading that again. So you can see that it's C97, and if I move away, move back, C97, and I refresh, see that this works differently now. The refresh actually changes the number. See, every time I refresh, I get a different number. So I explain this a little bit later. But we just take a look at the scope, and I build again, and then come over here and refresh, downloading the whole thing. 949, when I move away, move back, it's the same, right? It's the same number, but when I refresh, it also changes. So it looks like the singleton and the scope are working exactly the same way, right? Only transient works differently. And the reason for that, because this is WebAssembly. So the whole server-side code is actually downloaded. All of the DLLs are downloaded to the client side inside the browser. And inside there, we have this WebAssembly context, and all of them are actually hosted within that context, right? So, which basically means this program, this console application here, is actually running inside the browser. That's why every time you refresh it, it creates a new instance of this program, right? Because this program the console application is basically destroyed, and then it's recreated, and the main method is run again, and that's why you see even with singleton, it gets different number, different IDs every time you refresh the browser, right? And the scoped, because there's no connection and there's no request, so Blazor WebAssembly doesn't actually have a scoped lifetime management configuration. If you use scope, it's going to work the same way as singleton. All right, so that's everything I want to cover for today. There's one last piece about dependency injection in Blazor, which is about configuring owning components, and that one is probably not so, you don't use it so often, so I'm not going to cover in this video. You can go ahead and read the documentation. The components in Blazor are stateful, and with stateful components on the front end, you will very soon run into problems with state management. And that's why there are different architectures for managing this state, and one of them is Flux from Facebook. Today we're going to look at what Flux is and how we can implement it in C# and use it in our Blazor components. Alright, so let's get started. So with a component, whether it's a Blazor component or Angular or Vue.js or React, it does not matter. With a component, there's always going to be a view, right? And then, the user will interact with the view. And then that interaction triggers some events, and events are handled. Events are handled, and then handling the events will mutate the state. And then when the state is mutated, the view is updated. So you're in this triangle. But the problem is, if we only have one component, a very simple project, and we're maintaining the state in components themselves, within components themselves, that's not a problem. But once you start writing more complicated code, doing more complicated projects, you may run into situations where you have to share the state within different components. That's where we need to extract that state outside of the component, put it somewhere else in what we call a state store. And it's more look like this. So we have a state store where the state is stored. And then we have different components, right? And it will be the same kind of triangle, right? Because the user will interact with the view triggers some events are handled and mutate the state, right? And then the view is notified and updated. But in this case, it's slightly different, is that when the state is mutated, the notification is not only sent to one component, it will be sent to multiple components. In this case, you can see that notification is sent to this component 1 as well as component 2. So the same thing will happen if the user interacts with component 2. Then events are handled, and state are modified, and then notification sent to both components and update both. Right? So this is all good, and this is actually what we call a observer pattern. Right? So observer pattern, you have subject, and then you have observers. Right? So the subject in this case is going to be our store, state store. Right? And the observers in this case are our components. The observers actually listen to the subject of interest, to the store. And then as soon as there's anything changed in the subject, the observers will get notified. It's more like a push notification on your cell phone apps. And whenever there's a change, you receive a push notification, right? But you have a choice to react to it. So this is all good and works pretty well, but when your project gets more complicated, you will run into situations where one user interaction with the component will need to mutate states in multiple stores. That's where the dispatcher comes into play, right? For example, you're building this messenger app. You have a whole bunch of friends on your left. right? And then you have your user. You have your user component. So this is going to be your friends component on the left, your user component on the top, and then your message components in the middle. But what's happening here is that what if I log out, right? So I log out, and that message has to be sent to both components, right? So you would have a user store here, and then a thread store here, and then your message store here. 3 different state stores. But when you want to log out, right, that message has to be sent to both of these stores. Actually, all of the stores, right? So you would want to send to all of these stores. So that's when we need a dispatcher, right? That's when a dispatcher comes into play. So a dispatcher works like this. So same workflow, the user interacts with the view. To view, trigger some events are handled, and some actions are sent to the dispatcher. Dispatcher is going to dispatch the actions to different stores, right? And then the stores will mutate the states, and the states will update the component again, right? Update the view. If you're comparing this with the original store with only one store, this is nothing more than a 2-level observer pattern. So you would have your store as a subject and your components as observers. The second level of observer pattern is your store as observers and your dispatcher as subjects. Stores observes dispatcher as well. And you may notice that there are actions being passed around. Those are messages, right? And the reason why we need is because a dispatcher dispatches all kinds of different messages. And we need to distinguish the differences between the messages, right? Because they may be for different purposes. So that's why we have this action message object here being passed around. Right? Another thing to notice that these actions are like messages, right? And these actions, when the dispatcher dispatches the actions to all the stores that are registered to the dispatcher, the stores can make decisions to ignore it or not, just like you can ignore your push notifications on your cell phone app. So to simplify this architecture, the Flux architecture flow actually looks like this, right? The user interacts with the component send an action to the dispatcher. The dispatcher dispatches the action to the store handles the action and mutate the state, and then send a notification to notify the component that the state has changed. And then the view is updated. Okay. So normally, the Facebook team presents the Flux architecture flow like this. And I think the reason why they put action here is that they actually put methods within action instead of using it as a pure model, as a pure message. And that confuses me a lot. So I change it so that the action is only working as a message. So when I implement it, I implement it as a pure model. So let's jump into Visual Studio and try to implement it. First, let's create a Blazor app. Doesn't matter which one we should create. Let's use Blazor Server app. Alright. So we have this Blazor Server app created, and if we run this, Control F5, we see the default Blazor app as this counter. We're going to change this counter page to use a store instead of a local state. So if you look at the counter page right now, the counter component, it has a local state, right? And this local state is referenced in here, in the markup here. And the increment, the click me button calls this increment method to increment the count, and then it's displayed here. So what if we want this display not only in this place? What if we want to display the count not only in this place, but we also want to display it right here, right? So we need the state to be centralized somewhere, and that's when we want to introduce the store. So we may have multiple stores. So let's create a store folder. Okay. Let's call it stores, so that it may have multiple stores. And let's create another folder. Do we need another folder? Yeah, because we may have different actions, right? So let's create a counter store folder. And for now, let's just create a class. And let's call it counter store. And that counter store, it needs to have a state. Right, so let's implement a class that represents that state. Let's call it counter state. And then in here, we just need a variable that has a integer type, right? So we would want to have integer type count, and I don't want it to have a setter. So let's initialize this in a constructor. Right, that's it. So we have this that only has a getter, so that our state is immutable, which is better than mutable. This is where we're actually using that in the central place. And in our store, we'll have to use the counter state, right? So we'll use our counter state like this. Well, let's just call it state. It doesn't matter what state it is. So our counter state here, and then we'll expose a get state method. Right, so we'll get the counter state, expose this method, so we return this state, and here comes the observer pattern. We have to implement that. We have to have a listener. So I'm going to put these kind of code right here, right underneath here. So we'll have a private member, which is a listener, right? Listeners, right? We have this action that kind of like an event handler, but we use action so that it doesn't have actual parameters. So I have this private action listeners, and then I need to implement a add, like register the listeners, right? So we're actually, we call it add state change listener, right? Because it's listening to the store for state change. Right? So let's call it this way, and we're adding the listener. And what we do is that we just say listener, and then we have another method for removing the listener, right? And that's when we do this. And then whenever there is a change in the state, our store will broadcast that change. Okay, so we need a method to broadcast that change. Public, and then here we say listener invoke. We come over here. Yeah, so instead of using this local state, we need to dependency inject the counter store, right? So if we go to our startup class, configure services, we just add scoped, right? So because we don't want to share the state with all of the users, what is scoped is scoped to the connection, right? So we can have our store. Counter store. It's called counter store right here. Right. We're not implementing an interface just yet, so we're adding this one instance associated with that connection. So as long as the connection is not broken, it will be the same instance of this counter store, and that's good enough. So in here we just say inject counter store. Let's actually import this namespace so that we don't want to see. Right. So have that namespace imported, and then just delete this. So we have this counter store. So this counter store right here, so we can delete this, and then we can go over here and say counter store dot state dot get state dot count, right? And then our counter store will also, so let's actually use a region here, because this is boilerplate code. I don't want to see it all the time. So this is listeners. Well, actually, let's call it observer pattern. Observer pattern. Okay, so let's close this. And well, I want to implement increment count, right? In here, first we'll get a count. The current count, right? And then we'll increment the count, and then we'll create another counter state, right? Because it's immutable, so I had to create a new one, and then we'll call broadcast. We'll call broadcast change. Right? The same thing will be same kind of implementation for decrement. So decrement, and then the only difference is right here. Okay. So then increment count here we'll say, counter store dot increment. This broadcast thing, I want it to be, I want it to be private. So increment, and then we have to register our component to listen to the store, right? So for that, we'll override initializer, which is automatically formatting things in a weird way. So over here we would say counter store, counter store dot register dot add state change listeners, and we would just add an inline arrow function. We just say, whenever there's a change, I want to call this state changed method, right? So we have an increment, and then we state, and that's it. I'm not going to implement the iDispose interface and to dispose that. So just because I'm doing this for demonstration purpose, and because we want to also display that in the menu, so go to the shared folder to find the menu, navigation menu, where there is a counter, right? So in here we also want to inject. Right, so we want to inject the counter store and counter store, and let's copy over this code from here. So going to the menu, and so we have this, and so it will listen to the change, right? So we register this, and we add a listener so that the nav menu component will become another observer to observe the state change in the counter store. And right over here, we'll add a colon, and then we'll say counter store dot getState dot count. Right, and let's go ahead and look at our page. Refresh our page. No reference. Okay, so the problem is right here, we forgot to initialize the state. And to do that, we'll come over here and say, okay, the constructor. And then we'll say, new state, new counter state, and 0, right? So the initial value is 0. And then Control F5. Alright, so we have our counter number displayed right here, and if I click on it, it increases both places, right? So our observer pattern works. So that's the first step. What if we want to do some change and affect multiple stores? That's when we want to use dispatcher, right? So we don't have to use dispatcher. In simpler situations like this, it's okay to just use the store observer pattern right there, right? But if we do want to use the dispatcher, then we can implement the dispatcher. We have implemented the counter store with the observer pattern, and that works pretty well. And next, I'm going to implement the dispatcher so that we have the two-level observer pattern to implement Flux. The Flux architecture is nothing but just two-level of observer pattern, right? I've implemented the first level, which is this one, okay? And I'm going to implement the second level of the observer pattern. All right, let's jump into Visual Studio and work on implementation of dispatch. Last time I have implemented this counter store, which contains a counter state. This counter store allows the components to mutate the states in two different ways. One is increment the count, the other one is decrement the count. Right? So there's two methods that corresponds to that, and also it allows the components to register and deregister from the store. Right? So basically, listen to the store or remove the listener. Right? So add listener and remove listener. And if we go to our counter component, this is from the initialize method. We are adding the listeners, right? And then we're using dependency injection, inject the counter store into our component, and we're using counter store getState, count to display the count. And from our navigation menu, we also dependency injected counter store and displaying that store. And when we are increment and decrement, we can see the count changes in two different places. One is on the navigation menu right here. The other one is in the counter component, right? And that works very well. So today I'm going to continue implementing the dispatcher. Okay. So let's go back to our counter store, and before I continue implement the dispatcher, I want to point out one thing. Sorry, let's go to our counter component. I want to point out one thing before I continue working on the dispatcher, which is this add listener. I have the remove state change listeners there, but I didn't use it. And in my previous video, I said that this is a demo, so I'm not going to implement that. But I want to emphasize that this is very, very important, because the counter store is a dependency injected into our components, and the counter store is added as a scope, right? A scope, which is scope to the connection, right? This is Blazor. This is server-side Blazor. So add scope is scope to the connection. So if you don't refresh your page, the counter store will live as long as the connection. So unless you click on the refresh button, then that's, this is recreated. So that means that because we registered to the counter store, essentially we make the component has the same lifespan as the store, which is a scope, right? As long as the connection. So when you navigate away, Blazor framework is supposed to dispose it, but it cannot dispose it because the store holds a reference to the component. So it cannot dispose it. And when you come back to the counter component, it will create another instance of this. So because it cannot dispose it, when you navigate away and navigate back, navigate away, navigate back, it will create multiple instances with the same component, right? It will never release that, will never recollect that. So this is a memory leak that we have to deal with. So in order to do that, I want to emphasize that we have to deal with that, and the way to do that is we need to implement the iDisposable interface, and then inside of our code block, we need to implement the dispose method, where we have to say counter store remove what? So instead of using the inline arrow function, so if we use private void update view, right? And in here, we're going to call the state change. Okay? And then instead of doing this, we just put update view here. And when we remove, we also remove update view. So this is it. When the component is disposed, this dispose method will be called, and then it will deregister the listener, right? So we'll detach the counter from the counter store, which in turn allows garbage collector to collect the instance of the counter component. All right, so let's get started with implementing the dispatcher. So in order to implement a dispatcher, we need to, the dispatcher dispatches the actions. So we first have to implement the actions. So the actions, there are different kind of actions, right? So first will be increase, like increment action. So we add a class, increment action, right? And in there, we can declare a constant, which we can call it increment, or let's just call it increment, right? And then increment, right? But remember that we're going to have a decrement action. We can have all kinds of different actions. But dispatcher should be able to dispatch all kinds of different actions. So for that, we need to use polymorphism. And we can use interface. So we're going to have a iAction interface. Right? And for that, we will go outside here. We'll add another interface here. We call it iAction, and the action has to be able to identify itself about what kind of action it is, so that our store is able to distinguish what kind of actions is and decide whether the store will handle the action or not. Right. So for that, we need to have a read-only property, right, just to get the name of that the action. Okay, so we can have it like this, and so show that we're going to implement the interface. Right, so we have this, and then we're going to say we just return increment, and that's it. Right, so and we're gonna copy this and change this to decrement, because we are going to demonstrate two actions, right? Increment and decrement action, and then come over here, we call it decrement action, and then here we're going to call it decrement, and then decrement, and decrement. Again, I want to mention that the reason why we use classes as actions instead of just use a string or constant or enumeration is that sometimes action will not only carry the information about the name of that action to identify what type of action it is, but also will carry some useful information, like functional information in it. For example, if we were to allow our user to set the count of the counter directly, instead of just increment and decrement, we need to allow the user to input a number, right? And when we create a set number action, that action need to contain that number that the user input. In that case, having a class like this, right, and then implement a property like this. Well, it's going to be a number, right? Like this will help us to transfer that information from the component to the dispatcher, and from dispatch to different components that subscribe to the dispatcher. So that's the reason why we need classes. And another thing about the good thing about classes is that you can see all of the actions that the particular store has to handle. So now we have two actions, and let's go ahead and implement dispatcher. Right? Dispatcher should be outside of the store, so we're going to add a class right here, and let's call it action dispatcher. Action dispatcher. So action dispatcher will allow different stores to subscribe to it, right? So remember, this is a publish subscribe pattern, which is also called observer pattern, right? So first we need we need action, and we just call it registered action handlers, right? And then we need to have a public method register. Right? We register basically, or maybe we should call it subscribe. Right? Subscribe. So we're passing an action, which is delegate, right? Passing an action handler, and we're gonna call it registered action handlers. We attach the handler, and that's it. And another one will be the subscribe, and action handler as well. And only thing that is different is doing this. And of course, we need our, so actually very simple. We need our dispatch method, which will be called by our component, dispatch different actions. Okay, so we'll just do this, and then here we're just saying register. If it exists, then we invoke and pass in the action. Alright, to simplify this, we can include this magic wand thing and use extraction body. Right, and we do the same thing here. It will make it look way simpler. It's the same thing, but it will make it look simpler. But remember this dispatcher, right? It has to be called by all kinds of components. So we need to do dependency injection, and in order to do the dependency injection, we need to have an interface. And we don't have to do it line by line, so we can just go to edit, and then go to refactor, and then select extract interface, right here. We can also just do Control R, I, right? Control R, Control I. So this will, so I action dispatcher. Right, we're going to create a new file, and we are going to have all three methods to be included. Alright, so we implemented that, and the I action dispatcher is right here, and that's exactly what we need. Okay, now we need to go to startup, and right over here, and we don't want to do a singleton right here, because if we do a singleton, then the action will be dispatched to different users. We want it to be scoped to the connection, so we can call it, we can still use scoped, and then we are going to use I action dispatcher, okay, and associate that with the concrete implementation. And that's it for dependency injection configuration. So now we have the action dispatcher. We have implemented the actions, which are the increment and decrement action. Now what we need to do is we need to use it in our store, because our store need to be able to handle those actions. Right? So we will dependency inject. First, we will need to dependency inject dispatcher, and control dot. We'll select the second one. So we'll have this action dispatcher. So this is right here, and it put it right inside our observer pattern here, and I don't want it to be here. So I will put it up here. Actually, I'll put it up there. And then, so I have a dispatcher, and what we need to do is that we need to register to the dispatcher. So what we can do is action dispatcher dot register, actually subscribe, right? And we need to subscribe. We can put in our action handler, and where is our action handler? We don't have it yet, right? So right under done, under here we can create the action, the handler, which can be a private method, handle actions, and we need to be able to pass in different kinds of actions. Right? That's why we need an action, and then we can subscribe and pass into this. So this is the action handler, right? In here, so in here we're also facing the same question. Are we going to call unsubscribe here? Right. So are we going to implement the destructor, right? The finalizer that. Are we going to do this counter store, and are we going to say this dot action dispatcher dot unsubscribe handle actions? Okay. Are we going to do this? I would say we don't need to, because they both scope to the same action, same connection, right? So they have the same lifespan. So when one is collected, the other one is also gone. So in order to simplify our codes, I'm not going to implement that. So here we are going to handle different kinds of actions, and we have a choice to not handle every action, because dispatcher is going to dispatch all kinds of actions to all kinds of components that are subscribed to the dispatcher, right? So all components that subscribe to the dispatcher will need to determine whether the action is something that that they want to handle. So because every action has a name, right? So we can use that. So in here we can say increment action dot, remember it has a constant, so we can do this, right? And then decrement. If it's a decrement action, then it also has its name, action dot name. So we can in here what we need to do is we're gonna call the increment count that we implemented last time, right? And then here we're gonna call decrement count. And this can become private. Right, so we registered, right? We subscribed here, and then we're handling the actions right here. And now we need to go to our counter, because you're going to see problems here that this is private. Right? So in order to fix this problem, so we are not actually directly calling this method anymore. We are going to dependency inject our iDispatcher, action dispatcher. Right, so we call it action dispatcher, and then in this increment here, we're going to dispatch a action, and what that action is, it's going to be the increment action, and that's it. So this, because this is in the memory, it's centralized, and this will publish this action to all of the stores, and the store, well, currently we only have one store to deal with this, to all of the stores, and the store will determine that we're going to handle it or not in our counter store. Yes, we're handling both increment and decrement. Okay, so this right here, we will still keep it right here, because this, remember, we have two levels of observer pattern. So this is to attach listeners to the store in order to get notified when the state changes. So this we have to keep right here. The only thing we need to change is this action dispatcher thing. So instead of calling the store directly, we're dispatching this action through the action dispatcher, and that will actually publish the actions to all of the stores that subscribe to the action dispatcher. Right? So let's give that a try. So I'm gonna do Control F5, running the application right here. Yep, that works. Okay, so this is how I implemented the dispatcher. You can implement it different ways. Another thing you can do is you can have this action dispatcher action interface and iAction dispatcher. You can extract this into a class library and use it in different kinds of projects. And you can even implement a state store base. And in there, you kind of subscribe to the action dispatcher. And when you implement a state store, you can just inherit from state store base so that you don't have to do this subscription all the time. In this section, we're going to talk about authentication in server-side Blazor. First, let's have an overview of a typical authentication system and see what are the components in a typical authentication system so that we know what we are going to configure. Because to configure authentication for ASP.NET Core, there's many components. So having a big picture will help us to understand what we are actually configuring. Right? So there are three different layers of any authentication system. So we'll have the UI layer, which will interact with the users to register, log in, recover password, manage user profile, etc. And then we'll have the core functionality for authentication, which is to authenticate and to authorize. Right? So this is where we receive the user information and we authenticate the user information or authorize the information, right? So we will have a ticket, either a ticket or a token to deal with, and then we verify the ticket and see whether it's valid. That's authentication, and then we'll see whether the user has sufficient permission to access the resources the user is trying to access. So that's the authorization. So if it fails for authentication, then it will return HTTP 401, which is unauthorized, right? And if it fails on authorization, then it will return HTTP 403, which is forbidden. And last but not least, this is the DB or the ORM, or the DB and ORM is a combination. That's where the user information, the roles information, and everything else, the claims are stored, and the data is and operated, right? Like saved or updated or deleted. So those are the main parts of a typical authentication system. So now let's look at how we're going to configure them. First, let's create a server-side Blazor application. And let's select Blazor server-side, and let's change authentication to individual user accounts and store it under user accounts in app. Right? We're not going to cover the cloud scenario. And then let's click on create. So then let's first take a look at the project file. So remember, we have three parts: the UI, the functionality, as well as the database. Right? So for database, this is the package. Right? This is the NuGet package that we're using, which is the ORM, which in this case is the Entity Framework Core. Okay? And for functionality, we're using Identity Framework. Right? So this is the identity for Entity Framework Core. So this handles the authentication and authorization. And for the UI, so this is the package that contains all of the default user interfaces that handles login, logout, register, and all those other user interfaces. Right? And then let's look at the startup file and see how these different packages are configured. Right? How those three different layers are configured. So we have configure services and configure. So configure services are configuring those, basically the packages, right? And the configure method is actually configuring, for us, configuring the middleware, right? So again, we're going to look at our database or ORM configuration, which happens right here on the top, right? So this configures our entity framework, and it uses this connection string, which comes from this app settings, right? So this is our connection string. This is our database, and then the second one, this is configuring the functionality. This is configuring our identity framework, right? And also providing a identity user model. This model corresponds to the ASP.NET user table in our database, right? So basically this configures the identity framework, also connects from here back to the database here, right? And this is providing that model that corresponds to that. And this is the database context, which corresponds to the database. And then, so basically this configures the database, this configures the functionality. So which part is configuring the UI? So the UI is actually inside the solution, but this authentication state provider, this is when the UI needs information of the current login user. That's what this is for, right? So this gives us the user information. Then let's look at the configure method. And the configure method, it configures the middleware for authentication, right? So this use authentication and use authorization, there are two middlewares that handles the authentication and authorization. When these middlewares are being used, it looks for specific concrete implementations of certain interfaces like authentication handler, right? And those interfaces are actually implemented inside the identity framework, which we have dependency injected by using these calls. So then for authentication and authorization, it will use these injected classes to finish those works. And then last but not least, this map controllers configures the routing for our default user interfaces, because we're going to see that the user interfaces are not Blazor components, right? Not Razor components, but Razor pages. So those Razor pages need a default routing, which is the default attribute routing. And also this map controllers set up the default Razor page routing, which is actually according to the page structures. And that's now let's run this. So first we need to register user. We can use any email, doesn't matter, right? And then we're gonna give it a password, and then we register. This comes up because there isn't a database, right? So we need to apply our migration to create that database. Because if we look at our data folder, we can see this migration here that actually create all these tables, the roles, the users, and all of the other ones, right? The role claims, the user claims, and everything else, right? So these tables are only, for now, models in our C# code. So those C# codes has to be mapped to the database, and that database has to be created first. By clicking on Apply Migrations, it's going to run these migrations, and the database will be created. So that's Entity Framework. So I'm going to click on Apply Migrations. Right, okay, so register confirmation. So we click here to confirm our account. So normally this is going to send an email, but here it's just a dummy one. And then because we have already register, so we are going to log in. Okay, so we're logged in. Right now, we can access all of these. What if we log out? Can we still access all of them? Yeah, we can still access all of them. So then how do we secure our Blazor components? Right, to secure a specific component, for example, if we want to secure our counter and both counter and fetch data pages, then we go to the component, we go under pages, go to counter, and we give it attribute, right? So, which is, if you're familiar with ASP.NET or ASP.NET Core MVC, or so this is a attribute, the authorized attribute that you would usually use for your controllers. So we use this here, and then we copy it to fetch data as well. So now we go back to our component, refresh, go back to our page and refresh. That's good. So both counter component and fetch data component says not authorized. So this is how we secure our individual components. Another thing we can use is the authorized view component, which we can, the authorized view component is a templated component. So we can use that to, so it has two templates, which first one is authorized, right? And second one is not authorized. Right, so these are the two templates. And if we copy all of these, actually, let's leave the title outside to make it more realistic, because we're not going to hide our title, but we are going to hide everything else to be inside the authorized view. And then we say you are not authorized, please contact admin. Then here we can remove this and come over here and refresh the data, refresh the page. Going over here, we can see you are not authorized, please contact admin. Go to counter, you see not authorized, right? And so this is so removing that authorized, that's important. So don't use that authorized attribute, because when you use this, it's not controlled by the authorized view component, right? It's controlled by something else. So this, using authorized view and the authorized template as well as not authorized template, we have covered this. So if we revert, let's revert all of these. Okay, and we use this. So how do we provide a global authorized view? That's under the app component. So in here you can see that we have this authorized raw view, which is also a template component, right? So here we can give a global information about not authorized. In here it says you are or you don't have permission to access the page, please contact admin. Okay? So if we do this, you can see that you don't have permission to access the page, please contact admin. And if you go to fetch data, you see the same thing. So both of these are seeing this same message. So this is how you provide the not authorized message globally. But if you want to provide an individual message, you can use the authorized view, like what I've just showed. Another thing that you typically want to do is to utilize the user state or the user information inside your logic. So for example, under the home page, if we want to display some user information here, right? So we're going to go to our index component, which is the home page. So I'm going to delete this survey thing and then give some line break. And in here, if our logic requires user, it requires us to provide some to utilize the user information that comes from the authentication state. So if we go to our app component, the root component again, we can see this cascading authentication state. And this is similar to cascading value. We're actually cascading the authentication state down to the component tree. Right? So in order to use that cascading parameter, we need to declare a cascading parameter here. So first we have this code block, and then we're going to declare a cascading parameter, and that parameter is going to be, because by default cascading parameter are mapped to the parent level, the root level by type, right? So here is authentication state. So this is the type, auth state. We're gonna keep this as a private parameter. It doesn't need anywhere else, so we can use this. And then certainly we can use this as a in user actions for specific logic. But what I would do for the demonstration is I'm going to override the uninitialized async, and then in here we're going to say this auth state. We're going to actually await this auth state, right? Okay, let's change this to underscore auth state, and then here we're gonna say auth state, and we are going to use this. And what we're gonna do is I'm gonna say if auth state is not null, then we're gonna display some information about the user, right? So we're gonna say the username is state.user.identity.name. Over here, we're gonna loop through all of the claims. Okay, loop through all of the claims. And we're going to display claim type. Right, and then I'm going to display value. Claim type, claim value. All right, so this is how we are going to get the authentication state, which is basically we're using the login user information. So let's test this. We'll refresh the page. We don't see anything because we didn't log in. So let's log in. My password. And we don't see anything. Oh, okay. So that's because of this. Refresh. Alright, so we have this username, which is basically the email address, and then we have all of these claim type and claim claim values. Not very useful in this case, but could be useful if we add some more meaningful claims. At least this this name and the value, this is more meaningful. Alright, so that's how we use the authentication state inside our component. Next one is if we were to customize our identity framework model. So let's first look at our database. Okay, so this is the database. We're connecting to our local DB, right? So let's go to Server Explorer. So this is going to be our database and testing connection. Everything is fine. Click on OK. C is the tables. So we have the ASP.NET users table, right? It has all this information. What if we need something else inside here? Let's say we're designing a education system or a learning system, and we need a school information for each user, right? We need to be able to store in here. So then how do we customize the model? So in order to customize the model, under here we can create a class that we call it ASP.NET users, right? And currently, if we look at our configurations and their startup, which we have seen, it's using the identity user, right? So what we will do is we're gonna inherit from the identity user, right? Use our identity namespace, and so because we're inheriting from the identity user, so we will have all of the existing columns, but what we need is a new column that is called school, right, which has a string type. So for that, we're gonna go to our application DB context. In here, we need to provide our specific user type, right? The user model that corresponds to that ASP.NET users database, right? So we actually have this just created here, right? So just to be sure, F12 goes to the class that we just created, right? And the next thing we need to do is inside the startup, instead of use the default identity, we can just we can change it to use identity and change this to ASP.NET users, right? And then the second parameter, identity row, and then we would add a migration. So in order to do that, we're going to go to our tools, new Git package manager console. I'm going to say add dash migration. We say extended ASP.NET users. Alright, so build succeeded, generated the migration, the second version. In the up method, we can see it added school column. We go back to the console here, and we're going to say update database. Build succeeded. Okay, it's done. Let's look at our Server Explorer and whether we refresh it. Do we see school? Yes, we see school. Right? So we added this. So that's how we customize our model. So now let's talk about how we can customize our user interface. So if we look at the project structure here, we can see in areas, the areas folder, which contains some pages. Under account, we have a logout page, right? Then we have a login partial. What if we want to customize the register page, right? Where do we do it? How do we do it? We go to right click on the project, click on Add, and then in here there is a new scaffolded item. Click on this. We choose Identity, select Identity here, click on Add. Now it says scaffolding, right? It's trying to find inside that NuGet package what are actually included inside that NuGet package. Here we can see all of the user interfaces that we can customize. So we are going to customize the register user interface, and so this scaffold is going to connect from UI all the way to the database. That's why it needs to select a database contact, data context class, right? Which is this one that we have, and then we click on Add. And then it says it's scaffolding. All right, so under the areas, we are going to see a register reader page here, right? So we have this reader page here. What if we want a what if we want to add the school information here, right? So we're going to go over here, and if we look at our input model, which is here, email password, right? Confirm password. What if we need school information here? So we're gonna say school, and this is school, right? And on post, we're gonna say school equals input.school. So this user information then will be used later and to persist the data into the database. So our logout page is still using identity user. In fact, we can just search in the whole solution to see where our identity users still are, and then we'll replace all of them. So inside here we have identity user, so we're gonna have to use our identity user. Okay, to solve that problem, we come over here and we can say add default UI to go to default behavior, and then add default token providers as well. Right, that should fix the problem. And now let's run the application again. And if we register, okay, so we're missing the school field. Let's go to our register Razor component. Let's copy this. Right, so it's going to be here, and then school, copy and paste, and that should do it. Let's build the solution again. And come over here, refresh the page. We will see the school field, and let's do our tester at gmail.com. Let's tester2. Okay, and password is going to be our password, and school is, let's just call it my school, and then click on register. Okay, so I'm going over here, and then alright, so we have our page, and we're able to access all of these. So now let's take a look at our ASP.NET user table to see whether that email is there. Let's run a query, new query. I don't know why the screen is flashing like this. So let's select start ASP.NET users, and then let's run a query like this. And we have tester2, and the school is my school. Right, okay, so we have successfully customize our user interface to include our a new field, which is the school field, and we also successfully customized the ASP.NET users table by going through the entity models and add migrations and update database. I want to create a DataGrid component. I want my DataGrid component to be very similar to DevExpress or DevStream DataGrid component. At least I will have some column configurations. I will have the functionality of sorting and paging and perhaps something else as well. So in this video, I'm going to cover the column configurations. So let's get started. This is a server-side Blazor default template from Visual Studio. So let's create the DataGrid component. Under the controls folder, Blazor component. So in order to have the data passed in, I need it to be to have a generic type, and then from there I need to use the generic type to have a list of items. And let's call it data items. After that, I need to define, to configure the columns. And for that, I need my columns to indicate what kind of data field within the T item that we're going to use for the column, and what kind of caption, data type, and format and alignment as well. So let's have a configuration folder. Okay, and let's create that column definition class. Okay, so I have this. And what I need is data field. And I would need the caption as well, right? Because the name of the column can be different from the caption of that column. And then I would need a data type. So for that, I would need a data type class. Right, it has not set, string, number, date, date time, boolean, currency. And I would use it here as a data type. And after that, I will have a format. And this format is, I plan it to be a free format. That's why it's a string. And then I would have alignment as well. And for that, I will create alignment class. And that I will create it here. And it's going to be an enumeration as well. And it has not set, left, center, right. Okay, so with the column definitions, I want to have a constructor of this, and I want to initialize the data type to be not set. Now, everything is not set at the beginning, right? Alignment not set. Okay. And then let's go back to our component. And from the component, we'll have a list of columns as parameters so that we can define our column. And I need the controls to be in here. And the import file. So the namespace is here. So I have column definition. So I'll call it columns, right? And with this, I should be able to render and I'm gonna use the BOMA. Alright, so I imported my BOMA CSS file, and so with that, we're gonna start creating the HTML here. And for that, we will use a table because it's a grid, and class will be for width. Okay, so it's a BOMA class. And let's create the header first, right? So we'll have a row of header, and if we don't have the columns, that's where we're gonna use reflection to, to deal with here. We'll just we will need to loop through and here we need to create the th element, right? So it's going to be th and then the column, the caption. So let's test this. Let's use the index component, and let's import. I think we import that already, so we will have our data grid. Well, we don't, and that's because we don't have it yet. We have this. Let's import this namespace controls, and then we go back to here. We can have our data grid. And I don't know why it's still complaining that. Controls. And let's go back to here. And we'll data grid component. And we have our data items, column definition, and everything, right? So let's just use this for now. It's going to complain, but let's add this code here. And we need to initialize the definition and stuff. Okay. With that, we have I have some definitions created for I have some data created from previous videos, and I have extended that. So let's just copy that over. So I have an employee class specified here, right? And I need to define a list of employees in here, and I need to initialize that. I also need a column definition, right? And that is here. And I have my initialization method created already. So let's copy and paste that over here, and let's take a look. What it's trying to do is it's trying to initialize. If it's null, then we create a new definition, and that definition has name, title, department, employment date, and salary. And captions are name, title, department, employment date with a space. Salary is annual salary, right? And then we have our employee list hard-coded over here, just for testing the data grid component. So with this, we can specify the T item to be employee, right? And then we can specify our data items to use the list employees, and then we can use we can assign the column definition to columns. Okay, so with this, I expect that the components start showing, something. Okay, so we have nothing here. We have nothing here, and that's because we are not calling the initialize method yet. So we're going to override it, and we're going to call the uninitialize lifecycle event, so that our list employees, so that we can initialize this right here. Right, so both have column definitions. We're checking whether it's null or not on both attributes. So it's okay to use it in the uninitialized lifecycle event, because the uninitialized lifecycle event is actually being called twice. If you have watched my previous episodes, you know this. It's going to call twice on the first page load. So and we made a change, and go back and refresh the screen. All right, so we have our name, title, department, employment date, and annual salary. So that's pretty cool. And we notice that we have a space here and a space here. So it's actually picking up the caption, and that's pretty good. So the next thing we are going to work on is we're going to display the data, right? So for that, since we have already initialized the data, let's go back to our DataGrid component, and let's add the t-body element. And from here, what we need to do is we just simply loop through the data items, right? And in here we have the rows, and we just need to, go also loop through the columns and provide. So inside the double loop, we use reflection, t item, and then we just get property, get what property, and that's where the data field, the data field is being used here, right? Because if we go back to column definition, we can see the data field here, and if we go back to our initialization, data initialization, we can see that the data field, it corresponds to each one of the properties in the employee class, right? So here, we use the reflection and provide the data field as the name of that property, and that will get our corresponding property from the employee class, right? And here we just need to get value, and get value of what? Get value of the current item, right? And that should provide us with the data. And let's go refresh the page and see whether we have all of the data displayed here. All right, cool. So we have the data here, and we noticed something that, we want to have some formatting. The salary is not showing $, like it's not being displayed as currency, and the alignment for numbers should be aligned to the right. I want to see it to align to the right. I want the employment date to only display the date part. So we have some formatting to do. So let's first deal with alignment. And for that, we already have the alignment in the definition, and for alignment we have not set, left, center, and right. And to use alignment, we need to do something with header and as well as data. So let's deal with the data, since we just finished data here. So inside here, I think what we need to do is if column dot alignment is not set. Right? In other words, if there is a definition for alignment, then well, let's implement the else because it's simply just this, right? And if there is a alignment, then we need to have it here. So just say column dot alignment. Alignment. I don't know. Maybe you guys can tell me why whenever I type, whenever I use the IntelliSense, the dot goes to the end of that line instead of at the right place. I don't know how to resolve that problem. I tried space, I tried enter, I tried tab. It has that problem. Sometimes it has that problem. So then I go over here and I do toString, and then I need to make sure it's lower and lowercase, right? Because it's left, center, and right, and that corresponds to CSS style. So I can just use a toString here, and I think that's it for alignment, at least for the data part, right? And let's go back and refresh and see what happens. I'm expecting the alignment to be right, because if we go back to our definitions here, you can see that I have alignment to the right for salary, for the salary column, right? So yeah, so it's working, right? Then we need to have the header to be also aligned to the right. I need to go to the header part, and then let's see whether we can do the same thing. We just copy this and get it over here, and instead of using that complicated stuff for data, we just use this. And then here we use, we'll just remove this. And we say column dot caption and remove this part. And let's see whether we can get the alignment right. Okay, so it got the alignment right, but then it changed the it changed the style, right? So I think it got rid of the something related to the th, because the alignment that we assigned here. Oh, okay. So it's td. We use td. So let's go over here and refresh again. I changed to th now. Okay. So let's inspect and see what happens. So I have it on the other window and moving it over here. We have the alignment to the right, but something is overriding this, and that should have something to do with the th here. And that's, and what is that? Okay, so it inherits from something, right? So if I add it back, then if I remove the inherit, then it works. So I may have to add another class, and that's where I usually, in Bootstrap or BOMA, I create an override class. And let's take a look at and let's just create a override style sheet. So style sheet, style sheet, and I'll just create a, let's call it BOMA override. Okay, and in here I will have I want to create a alignment. My style is also targeting TH, and I want it to align to the right. Okay, and that would have text align to the right. And since I'm trying to override, so I'm gonna use important. And since I'm doing this, I'm gonna create for left, center, as well as right, all of them. Center, right. Okay, so, and I have that, and if I go back and I just alignment, right? So in here I have to do switch statement, switch column dot alignment, right? Case column dot alignment dot case alignment dot left, right? And case alignment dot center, case alignment dot right, and another case just do nothing in other case, fix this typo. And I think the formatting is weird, so let's format again. Okay, going back up, and so instead of using it right here, let's put it inside, and we need to use the class that we just created. So we have class, and I will call align left, right, and center and right. So here we have center, and then we have right over here. And if it's alignment dot not set, or if it's default, then we use nothing, and that should be okay. Let's see what happens if we refresh our still not working. And why is that? Inspecting. Okay, and we have our class. Where's our class? We have the align right class, right? But it's not loaded. Perhaps let's go to, I think perhaps we need to the style sheet here. So we have this already here, and I need my BOMA to be here, and I also need my BOMA override to be here as well. And let's see whether this would fix that problem. Okay, all right, cool. So we have our class correctly applied here. Next thing is I want to have the formatting as well, and for that I planning to do something simple. If we go back to our here, where we define our columns, if we have our format, see, I have this data type as currency. I have this format as well. And I have the format here as well. So if there is a format, then I want to format it. Otherwise, I'll just leave it alone, right? So going back to the DataGrid component, and we need to add some formatting in the T-body area, right? And that's where we will have some kind of if statement, right? So we would say if the format is not empty, right, or null, if column dot format is not empty or null, and f column dot data type. We also, because the format is kind of dependent on the data type, so I also want to say, you know, if it's set already, then I would actually format it. And in here, I also need to do some switch statement. According to, you know, different data type, I would format it differently, right? So if it's date, is there a date? Yeah, it's just date. Or if it's a date time, then I would, you know what, I'll create a string here. Right, and this is the value, and if it's a date or date type, the value would be datetime dot. I would parse the, because this value is basically an object, so I would have this, and then I would call toString. Oops, to y. Oh. Okay, so toString, and then I have, you know, I have this, and then I just toString, because this is a datetime, and then I use what? I use the column dot format, right? And that should do it. So that's for date or date time. And if it's a boolean, then we're gonna do it a little bit differently, right? We're gonna say value equals, again, it would be similar to the datetime thing. We just, instead of datetime, we use this. We're gonna parse it, and then we're gonna, we just say toString, and this should give us whether it's true or false. And then if it's currency, if it's default break format, why there is a problem here? I don't know why. Okay, there's no problem. So if it's a currency, I also want to just copy this over here, and so I'm gonna use, you know, it's double, and I want to parse that value, and this would give us currency, I just, you know what, I'll just use this. And I also want to run it. So I will use mass.run, and I'll provide this should be okay. Okay, so I run it first, and then I convert it to currency format. So then I have the format here, and so I have the value here, and so I have the volume value here, and this here there was the alignment, and I just need to put the value. So instead of this, I just need to use the value, I think, right? And that will be like this, and yeah, same thing as here. I'll just put the value here. What's the complaint? It does not exist. Oh, it's right here. Oh, okay, okay. That value is supposed to be inside here, right? So that's when it has format. And if it does not have format, well, yeah, it should use the original, which I got rid of. Yeah, so let's revert. I'll copy this first, and I'll revert. Okay, that's good. And then I have it right here. And else, so this if statement is if there is a format, right? So we're dealing with otherwise here. Otherwise, we just use the original one, which doesn't deal with any format. Okay, so I think we're good, and going back and refresh the screen. All right, so cool. We have our employment date format. We have our annual salary as well. So I think that's what I want to cover for today. I covered column definitions, column configurations. I covered formatting, and I covered alignment. Let's implement page. For a paging, under the configuration folder, I would need a paging configuration class to be able to configure paging. So I would create a class, and I would call it paging config. And I think I would, yeah, let's make it simple. So I would have an enabled property and page size, and I would also have yeah, let's have just these two for now. So yeah, in theory, if given a page number, we need to go to that page, right? And we can do that with link query. So with link, right, in C#, given a number of, let's say we're working with data items, right? So we can use link query like this, data items dot skip. So if we are on page 1, then we skip 0 number of records, and then we take how much? We take the page size, right? Let's say each page size has 10 items. Each page has 10 items. Then I would say skip 0, take 10, right? And if we want to go to the second page, then I would skip 10, right? And take 10. Knowing this, what we can do is we can implement some of these functionality here. So for example, I want to know how many items to skip, right? So I would implement a function here. I want to know the number of items to skip, and I need to provide the current page number, right? And if enabled, right? So if paging is enabled, then we would apparently it would be the current page number minus 1 and times the page size, right? Because for example, if it's we want to go to page 1, number of items to skip, well, let's call it page number, not current page number. It's the page number that we want to go to. And let's say we want to go to page 1, then this would be 0. So number of items to skip is 0. Otherwise, if it's not enabled, right, then we would return 0, simply 0, right? So we're not skipping any items. So if this is page 2, we want to go to page 2, then number of items to skip is the same of the page size, right? So if it's 10, then we skip the first 10 items, so on and so forth. So the next one is, number of items that we want to take, right? So I want to implement that too, number of items to take, right? And again, if enabled, right? If it's not enabled, number of items to take is basically the total number of items. So I need to provide a total items count, and we are returning this total items count. By the way, I got a silent keyboard. It's not that silent. It's not silent, but I think hopefully it's quiet enough and won't be so distracting. So if it's enabled, then we are basically returning the page size, right? So if we only have, let's say if the page size is 10 and we only have 2 items in the list, I think by returning page size 10, and we're executing link query take 10, I think it will not throw an error. Let's see what it does. So we have the number of items to skip, we have the number of items to take. Next one is that we basically want to go to a specific page, right? So if we know a page, then we can just use these 2 functions to go to that, to know, along with the link query, to go to that page. But what if we just want to go to the previous page number or the next page number, knowing the current page number? So I'm going to create those functions first. Okay, so let's do the previous page number given the current page number. Right, so that's easy, I think, if it's enabled. Well, no. If we want to go to, then it has to be enabled, right? So if the current page number is greater than 0, then obviously we're returning the current page number, greater than 1, then we're returning current page number minus 1, right? Otherwise, if it's not, then we're just returning the first page. Right? So this is the edge case scenario. So we don't want to return minus, like negative number. The next one also, like the next page also has a edge case scenario where when it reaches the large page, the last page. So for that, I want to pass in the total items count because I don't want to exceed that. So that condition, we should say that if the current page number is smaller than maximum page number, right? Well, we don't have that. Let's just put this here, so that in our mind it's clear. So if it's smaller than that, then yeah, we can just return the current page number plus 1 because we want to go to the next page. If it's not smaller, meaning that we're already on the last page, then we just simply return the current page number. Right. So how do we know the maximum number, a page number? It has something to do with the total items count. So I'm going to create I'm actually going to create another function here, and that I will call it max page number, and providing the total number of items. Right, and here I'm going to say I need to know the total number of pages, obviously, right? So that is I think it's, yeah, so it's number of pages equals total items count divided by the page size. But these are integers, so to receive a double, I want to force a conversion here. Knowing the number of pages, then we just need to do some, so if it's the same as the floor, number of pages, right, then the maximum number of maximum page number, so we're basically returning this, which you can say max page number, so max page number equals the number of pages, and it's complaining, yeah, this is double, so just force it to integer. Otherwise, if the number of pages is not a integer, then it's greater, so the maximum page number must be equal to number of pages plus 1, right? So then here I just return the maximum page number. Okay, so we have the maximum page number here, and I can use this here and pass in the total items count, and that we will get the next page number, previous page number, next page number, and I think we're good now. Now let's jump back to the component. What we want to do here is we want to display, so we have this, currently it's going through all of them, all of the data items that we have, and display all of them. In this case, there's no paging. But if paging is enabled, right? Because in our paging config, we actually use the enabled in these two functions. We're checking whether they're enabled or not, so we can just use that directly. So in here, we would say we're looping through items, but it's filtered, right? We want to skip. We haven't declared that paging here yet. So let's define that, declare the paging parameter, which can be passed through the parent component. Basically, the developer provide that information, and that's paging config class that we have just defined, and let's call it paging, and let's go back and say if the paging dot skip, not if, we know that paging, and we're skipping the number of items to skip, right? And it's a function that we need to provide the current page number. So the current page number has to be, let's make it a parameter, initialize that to 0. Because you see that current page number may be used by the developer. Yeah, so let's do that for so in the case that the developer I'm going to provide a custom pager, in that case that current page number needs to be exposed to the developer, right? So, and we can initialize that to 0. And current page number is going to be skipped over here, right? And then we want to take, that I think we skipped, and then we take, and how much we want to take, how many items we want to take, which we can just get it from the number of items to take, which I need to provide. So this part we have defined, and we want to, it takes the total items count, number of items to take. Let's think about whether this function is right or wrong. Number of items to take. We provide the total items count, and if paging is enabled, then we return the page size. Otherwise, we return the whole thing. Yeah, I think that's right. So here we need to provide that total number of items, right? And that's count like this. Okay, so we changed this part, and that should render our data items correctly. Now we need to provide the pager. We need to provide that pager. So let me search for DataGrid pager images. Let's see. So it's on the other one. So go to images. I think I want to do a simple style. I don't want to display all these numbers here. I think I will use something like this, right? Okay. So let's implement the pager here. Again, I prefer use the BOMA style, which we can just use level. Okay, so if you haven't used level, you can go to BOMA website and we can use BOMA. It's actually pretty simple, right? So in order to I want the pager to be on the right hand side, right, which is similar to DataGrid in DevExtreme. And under level, I can just say level to the right, right? And within it, I need to provide another one, which is level item. And here I can just define. So here I would say if paging is provided and paging.enable is true, in that case I would render the pager. And this is predefined pager, and I want to also be able to give the developer the option to provide custom pager. So going back to the paging config, I want to add another property here. I want to say boolean and custom pager, right? So if it's a custom pager, then we render the custom pager. So if paging dot custom pager, then we render the custom pager, which we can provide a render fragment here as a parameter. So, which I also covered in one of my previous episodes. If you haven't used render fragment, and this is going to be a simple render fragment without a generic type. So render fragment custom pager. So And it's pretty simple to use, going back over here to say if the custom pager is enabled. If we want to use custom pager, then just use custom pager. That's simple. And then otherwise we use our predefined pager here. And the predefined pager for now, I just want to use buttons. I want to have, we use button for now, and then we'll change to a better style. So button in BOMA, it's simply called button. And then, and this is called previous, right? And then we'll have a next button as well. We just want to make it work for now. And obviously, when the button is clicked, we want to go to pre-pref page. Okay. And again, when its next button is clicked, we want to go to next page. Right, so let's implement these two. Yeah, I think these two should be public. Because for custom pager, these two has to be public, right? So go to previous page, and then go to next page. And with that, we can use the paging functionality to say, current page number. We basically reset the current page number, right? And then that current page number can be just used in here, right? And so that we know how many items to skip. Yeah, and then we use take to display. So current page number should be equal to what? Should be, we have that paging next page number, which we only need to provide the current page number, right? And total item count is just data items dot count. And what if the data items is null? Do we have a columns is null? Create a header with reflection. The columns is null. What if the columns are null? Okay, so that wasn't handled properly yet. Alright, so this has to be handled to see whether, otherwise it's going to throw exception, but I'm going to assume that the developer will take the responsibility to populate the data items. Right, so data items shouldn't be null. Let's assume that. And if you want to extend my code, you can go to my GitHub and to extend that. So next page number is this, right? So, and this one is also the same thing. Paging dot, wait, this is previous, so this is wrong. Sorry about that. So this is previous page number, and I should only take the current page number as a parameter. So we have the previous, we have next. What else do we need? We probably don't need anything else. And let's give it a test by providing the configuration. Let's go to the index page, and we need to provide the paging definition here, and we could just use inline, and we can just say paging configuration here. And what do we have? We have enabled, so I want to enable, right? And what else do we have? Here we just say custom pager false. Page size, let's use, how many items did we provide last time? I think it was 10 items, right? So let's say we have 3 page size. And we can test the scenario that the last page should only have one item. Let's see whether that causes any problem. So this should be working. Let's see whether it works or not. So I'm going to just run Control F5, so that enables the hot reload. Okay, so we have the previous next button. Unfortunately, I want it to be on the right, but it's on the left. So let's see what went wrong here. So going back to the DataGrid component, I have level. Maybe I need a level left. Where did it go? Okay, so I'm putting a level left here. And then we go back and refresh the screen and see whether that works or not. Okay, yeah, an empty level left solved the problem. And I see 3 items, right? Hopefully that's, I'm gonna click on next page, I'm gonna see something magic happens. Oh, it works. Okay, it did work. 1, 2. So this is on the 3rd page, right? Because I clicked twice, and the last one should have only 1 item, which is great. So it's working. So that take functionality, I'm saying take 3, but there's only 1 item left, which is fine, right? It didn't cause any problem. So if we're going back, and I'm clicking, yeah, this is on the 1st page, so no matter how many times you click on it, it's not going to go, because we always return 0. Yeah, number of items to skip is always 0. And then we take 3 from there, right? So let's see what happens if we change that to 2. Right, so to 2, we're gonna have 5 pages. Okay, so first page, it's weird that I can't click, like the first click did not work, and then the second one started working. So this is the 2nd page, and then the 3rd page, the 4th page, and the 5th page, which is right. So it all go all the way to the first one, and then if I click on the next, it's working. But then something is wrong. If I refresh the page and click on the next button for the first time, it's not responding. And let's check what's happening. Yeah, let's check what's happening. So I have this. Oh, so this is index page. So I have this next button, event handler. And the current page number was set to be 0 at the beginning, right? Oh no, the current page number cannot be 0. I'm surprised that it's skipping correctly. So if I provide 0 here, what's going to happen? If it's enabled, so if it's enabled 0, oh, it's going to return -2. Oh, so skipping -2. All right, so that's something wrong there. So yeah, I think the initialization is wrong, which I have to fix in here. So the first page number should be 1. And let's go back and refresh the page and see whether that fixes the problem or not. All right, so I'm clicking on the next button. That works. That solved the problem. Okay, last one. First one, let's play with some other numbers here just to make sure all of the edge cases are covered. So index component, and what if I use 4? Then I would see 3 pages, and last page should only have 2 items, right? So click on refresh. All right, so 4 items, first page, 4 items, second page, 2 items, last page. and that's working very well for me. Okay, cool. So I need these buttons to be gone. I don't like the huge fat buttons to be here. I want to be a little bit prettier than that, which I will do going back to DataGrid and replace the buttons with actually, before doing that, I want to show which page we are on first, right? So I want to have a span here, right? And then I want to show number of pages, current page number, right? Current page number of the total number of pages, right? So we do have a maximum number of maximum page number here. Again, this problem happened. So I need to provide the total count, right? So data items dot count. That should be good. Takes a long time for this to disappear. I don't think I did anything wrong. Okay, good. All right, going back, and we'll see whether that's better or not. All right, so page one, well, needs some spacing there. At least it's showing the correct result. All right, so we need some spacing. Need some spacing here. NBSP. I'll put 2 over here and 2 at the end, and that should be pretty good. All right, that's good. Okay, let's replace these big buttons to just use span. And what should we do with the span? I want it to be bold, and I want to just use just use this. Right, so for previous, just use the less than sign, and then this would be greater than sign. Greater than sign, right? And yeah, so bold, greater than sign, and that should be, well, I should have just changed the button, but go to the next page. Right, so that's fine. Alright, so let's see whether that looks okay or not. Okay, cool. So we have these. I think this is wrong. It should be the other way. So I think it should be this side. And then any other thing I want to change, I think I want this to be smaller, and then I want to have a cursor, pointer cursor, right? So I'm gonna use inline style. Font size, yeah, I want it to be bigger. Let's use 14, and then the cursor is going to be pointer, right? And I'm going to use the same style here, and I want these to be smaller size, and definitely not cursor. Oops. So I want this to be smaller, and I want it to be not as prominent as the buttons, so I want to change this to, yeah, gray. Alright, so let's see what happens. Okay, I like this look. If you have the time, you can kind of make this look like disabled when we are currently on on the first page, right? And then make this look like disabled when we're on the last page, which I will not do during the video. So yeah, so I think we have done a pretty good job. And I just want to perhaps cover the custom pager, right? What if we want the developer to provide a pager? So we have partially implemented this custom pager here. So what if we go to here and then we enable this? Oh, sorry, it should be true. Right, custom pager equal true, and we go back. I expect this pager to be gone, right? This is predefined pager, like we just defined the pager. Yeah, so that's gone. So the developer need to come here and provide that pager, right? So we have that custom pager here, and what should we do here? We should have maybe we should just use buttons, or yeah, let's use some buttons, right? And instead of so let's make it look a little bit different. Let's use bootstrap, right? So btn primary, yeah. So you see that blue button, which I don't like, but just make them a little bit different, right? So we'll have previous, next, and what should we do? So the previous button, when we click, we need to call a function like this. Oh, this is previous, right? And this is next page. Well, for to make it clearer, so let's use a different function name than the one before. And I'm gonna call it pref and next here, and then at the bottom here I'm going to use private function pref page, and I'm gonna call the grade dot, go to next, well, go to previous page, and then void next page, grade dot, go to next page. Okay, all right, so we have our previous and next button. Let's see whether they work or not. Click on next. Well, it's doing its job, right? I like it. It's doing its job. Previous one is not working. Previous is not working. Oh, and there's a typo, and it doesn't even give me an error. That's very weird. Alright. Okay, so Control F5 again. Next, previous. Okay, everything works. So what if I want to provide that number of page per page number, off page number? So I'm going to go over here and copy this. Where is it? Where is it? Here. Okay, so we have this over here. But what I want to do is, instead of provide this just as a label or read only, I actually want to implement a input control here, right? And that's number, right? And I think there is a maximum, and that maximum number is supposed to be, I don't know whether when I call grade it's going to give you any problems, right? Maximum number. Oh, it's not returning the maximum number. So I gotta go back and return that maximum number. So that's going to be a property of maximum number, maximum page number. Right, and it's going to be read only. And I believe it's going to be paging dot y. Oh, not supposed to be. If I just say paging dot, yeah, okay. So maximum page number. Do I need to provide the total? Okay, I do. So data items dot count. So going back, and I'm going to say maximum page number. Alright, maximum page number is a property. And the minimum is 1. Right, so, and we want to bind this to current page. Did we display that? I think we did. The current page number is a parameter, right? I don't know whether we can just do this. Current page number. Let's see whether this works or not. So we just use this. I'm going back and refresh the screen. Okay, it worked. See, I have this input box, yeah. So, will it work? We'll go to next. Alright, cool. Right, so I have 3. What if I type 4? Uh-oh, 0. Nothing. What if I type -1? Not the first page. Great. So I'm now going to demonstrate how to control these numbers. Yeah, I'm not supposed to go under 1. If we use these buttons, it's actually doing that control, but we can actually type in any number we want. But it's not actually creating any issues, like any exceptions. So yeah, we definitely got to control this number so that it doesn't, if we type in 8, the moment you leave this, like the focus, the moment the focus leaves this input box, it should revert back to the, I believe it's 3, right? The maximum page number. I want to add the sorting functionality, and first thing I want to do is to find the arrows to indicate a sorting functionality. And on Dev Extreme or Dev Express, the sorting functionality actually has, they support both single column and multiple column sorting. I only want to implement single column sorting. And first I want to find the arrows. So it's going to be CSS arrow. And usually I'm pretty happy with the W3 Schools CSS, and I think I like this up and down arrow. So I'm going to use these styles, and so I'm going to go into my CSS folder and create a DataGrid class style sheet. And that's going to be DataGrid. And in here, I'm just going to paste this here. And so this is the base one. I want to change to sort instead of arrow. And I don't need right, I don't need left, I only need up and down. So that's pretty good. And the next thing I want to do is go to my component. And I want to go to my component and I'll find a place to apply this style. That's going to be my header. It's under my header, which is somewhere here. Yeah, it's going to be somewhere here. EH. Alright, and I think I'm going to add a span here. Right, and that's going to be want it to flow to the right, just like in DevExtreme, right? And the class, I want to call a method that's called class, sort class, and I want to provide the current column, right? Of course, we don't have this method yet, so let's go here and create one. It's going to be private method, and it's going to have sort class, and here we're going to have our column definition, and our column here, and that's going to be, the logic would be something related to the sort direction, and we haven't created the sort direction configuration yet, right? So we have to add a class here, and let's call it sort direction. And it's not going to be a class, it's going to be an enumeration, and that's going to have not set, right? Ascending and descending, and that sort direction has to be also added to the column definition. And from here we're going to say prop tap tap and use the sort direction right in here, and we'll call it sort direction, and we initialize that sort direction to not set, sort direction dot not set. Okay, that's good. And then in here we're going to have a logic. We need to check whether the sort of direction is sorry about that. So the sort direction is set or not set. If it's set already, if it's set already, then we are going to return, because we go to this class, so we'll see that how they're using it. They put the arrow and then the direction, right? In our case, we are going to use sort, because we changed it to sort instead of arrow, and then this direction is going to be column dot sort direction dot to string and to lower. This is very similar to alignment. We can use that, the enumeration to string. And if it's set already, so of course here this has to be a string, right? And if it's set already, then we return something. Let's call it no sort, and we are going to add this no sort thing in our CSS DataGrid here, and we're going to say no sort. And because we are using it on a span, so the only thing we want here is to say display equals none, which we're trying to hide that span when there's no direction. Right, so I'm pretty happy with this. Going back to the header place, this span will need sort class. Yeah, so it's already coded here. That's pretty good. And we will actually need this on all of that. Okay, so it's going to be this part. Well, actually, I'm just going to copy this over to here. And this code should be cleaned up. I'm just using this just so that it's clear what we are trying to do. But we should use some sort of function to clean up this this whole thing here. So we have our direction. Yeah, we have our direction, and so we can test this by initialize our data. So we're going to go in here, and then let's say I want to sort with name. Right, so sort direction equals sort direction dot ascending, and then we're gonna go to our application, refresh the page. Okay, so it's not being displayed. I wonder why. So I'm gonna inspect. Okay, So in here, I do have my span. Oh, I see. Because I included that CSS, but I didn't reference it in the host.cshtml. So of course in here I need to include my new class, which is I'll use this. Actually, I'm going to copy both of this to be included later then at the last place. So in here it's going to be DataGrid, right? Okay, and then we just need to refresh again. I'm going to do a Control F5. Alright, so this doesn't look like it's the right direction. Did I? This is a weird direction. Let's go back to our CSS and see what actually happened. So direction is, oh, okay, so I forgot to change this because it's gonna be ascending or descending, right, which corresponds to our direction in the enumeration, which is where is it? Yeah, in this enumeration we have ascending and descending, and in our component sort class we are using this toString, so it's going to be either ASC or not set or DESC, right? So in here I just change that to corresponds to the enumeration, and then if I just refresh this again, then it's good. So we have well, data we haven't sorted yet, right? But we have already initialized our data to be ascending. In here to be ascending, right? We have this to be ascending, and then it's showing a up arrow, which is correct, except the alignment is a little bit off. And see what we can do to adjust this. So we have this here, and then so let's see whether we can do something about it. So this is ascending class in the DataGrid, and we want to do something here, and I wonder whether I can add some kind of, you see this using padding in the sort. Let's see whether if I add some padding here, what would happen in the ascending place. If I add 3 pixel, what happened? 3 pixel of padding. Didn't do anything, right? Did it do anything if I change it? Oh, okay, padding just make the size change. So what if I add some margin and add 3 pixels of margin? Let's do the change. Actually, okay, so it's actually seems pretty good. So if I use margin 8, then that would be probably okay. So let's go to my component and then go here, and so if I do margin 8 pixel, that's going to be probably okay. And the next one we're going to test is let's make this descending and see what happens. So for now we're not sorting the data yet. We're dealing with the arrow, the indicator of the sort direction. Okay, so we also have this problem, and we want to add this as well. And we added margin last time. Let's see what happens if we use 3 pixel. I think 6 is pretty good. Maybe 5. Yeah, let's use 5. So let's go to our DataGrid, and under here we would say margin 6 pixel. Do we say 5? Okay, 5 pixel. All right, so we're happy with our direction, the indicator of the sort direction. And the next one is we need to sort our data. And to sort our data, let's go back to the DataGrid component. And in here, whenever we click on the header, we want to unclick, right? We want to sort data. And we also want to provide this in here, and usually to do it, to call it that way, we yeah, it's gonna complain, so we use our proper syntax here to provide that. And let's define this sort data function, and that's going to be sort data here. And again, it's passing in the column definition, right? And column, right? And in here, what we want to do is, because we only support single column, because we only want to support a single column sorting, then first of all, so what is this column? This is going to be the column that you click on, right? So it's going to be sort by column. Let's name it meaningfully. And what we are trying to do here is, because you may click on one column and then you click on some other column. So first of all, we need to clean up the sort direction on other columns, because we only want to support one sort direction. We only want to support sort direction on one column. So first of all, I want to run through all of the columns, right? And then if our column.data field doesn't equal to sort direction dot sort by column data field, if it's not the same data field, then we will set this column to sort direction dot not set, right? So then this reset any other columns that had a sort direction already. And then we're going to switch, we're going to see what direction we are on currently for this column that we're clicking on, right? So if it's not set, right? So if it's if the current column is not set, then we are going to set it to ascending. If the current column is already set, and if it's already set to ascending, then we want to change it to descending, right? And if it's set to as descending already, then we change it to ascending. And if it's default, then that should not, in theory, happen. But if that happens, we just set it to ascending again, right? So that changes the, I think, a typo here. That changed the direction. That set the correct direction, right? And then we're going to look at our direction that we just set. Right, so if it's ascending, then we need to order our data. So we need to order our data by using the sort method, and that has a overload, and we just need to provide the comparison delegate. And I think what we should do is to basically we can, so at the X is T item, right, which is our, in this case is our employee, I think. In this case it's our employee, right? but it's T item. So we have to use reflection here, and then we just need to get the data of X, and then data from the Y, and then convert it to string, and then we compare them. Right, so we gotta use reflection again. So we're gonna say T type of T item, and then we got property, right, and then we get this data field from the sort direction, a sort by column, and then we can get value. Get value of the X, and then we change to string, right? And then because string has a compare to, so we can then use compare to. Compare to what? Compare to Y. So it's going to be the same thing here, but then we change this to Y, right? And that's all we want to do. Did I close this? This is correctly right. What is complaining? Okay, so no complaints. Good. And then if it's the other way, then we just copy this, and then instead of using X here, we change this to Y, and then we change this to X. Okay, that should do. And then this should be called in here. Did we implement that? This should be called in here, providing the column that is being sorted. And also we want to make sure the same thing is being called in all of this column again. This should be cleaned up, but I'm not going to do that here. I think in my GitHub I have already cleaned up the markup. So let's go to our code here and close this and refresh. All right, so we have our we have our header, and this used to be descending, and this definitely wasn't sorted yet, right? So we're missing something here. So the initialization is not working. So what we should do here is that we should call our sort data method when we're initializing the DataGrid component, and that should let's implement. Let's override the onParameter set, and then in here we need to call the sort data. But which column are we? I think we need to modify this method to make this a default, as a default value, which is null, and then we need to check if this column is null. That means we already had a sort direction configured in the initialization. In our case, in this case, it's the first column, name column, right? So in this case, if it's null, then we need to say sort by column equals to the column's definition. So there's got to be a column that already has a sort direction. So I need to find a column that already had a sort direction, which means not set. And then if we cannot find it, which means if the sort direction is null, then we're not doing anything. Okay, so did we call it properly? Double check. So we call it here, 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 and then here on parameter set. Okay, so let's go back and see whether it works. Everything is sorted, but I'm wondering why it changed to ascending. And if I click on it, it does work. But why is it changed to ascending? Did we code it correctly? So if it's not set, okay, if it's set, then we find it, we get it, and then we clean up here, and then if it's not set, then it's ascending. Oh, okay. Yeah, so this will change it. That's mimicking the behavior that we're clicking on the column, but we're not clicking on the column in the in here. So we have to say that if sort direction, if sort column, so we're gonna have a here is because it's called initial equals false, initial equals sort by column. So if it's not, then its initial is going to be true, otherwise it's going to be false. So this has to be false. If it's not the initial method, then we're going to change direction, otherwise we're not changing direction. So hopefully this will fix it. Okay. Let's refresh. Alright, so yeah, this looks right. Okay. This looks right. Let's change this, let's add a cursor here, right? So which is going to be part of our DataGrid class. And that's going to be, it doesn't matter whether it's ascending, descending, it has to be added here. So it's going to be cursor, it's going to be pointer, and then let's refresh, and that should do it. That should do it. Why it didn't work? Did I save it? Oh, okay. This is not the right place. This is the span. I think we need to add, yeah, we need to add this cursor thing here. That should do it. Okay, yeah, it's working. And then if we click on this, okay, this is working. And I like the alignment as well. Okay, yeah, sorting works pretty well. Okay, so now let's see whether the sorting works with the paging. I hope I don't need to make any changes. So I need to go over here, and then I need to re-enable the paging thing. Paging is enabled in here. Okay, and refresh. Okay, so we have our paging enabled, and looks like the sorting is just working fine with paging. So JKL-RT, and then we test with if we test with the number here, it's also working correctly. Alright, so alright, cool. So we implement our sorting functionality. This is the end of the course. I hope you have learned something, and if you enjoy this kind of content, feel free to come to my YouTube channel at youtube.com/FrankLiuSoftware. Thank you so much for watching.